Thank you. Minuten und wir beginnen. Ladies, gentlemen, distinguished colleagues, dear friends, it's for me a big pleasure to start this award ceremony and also the plenary session. I have to admit I'm quite nervous. It's my first award and plenary session, and my predecessor, Isabel, put the bar of the expectation very high, so I will try to do my best. You have seen we have changed a little bit the format of this award ceremony and this plenary session. We will start today with Leroy Award. Actually, I have to correct myself. And many of us actually always say that this is Leroy Award, but actually is Leroy Award. And before announcing the winner of this year Leroy Award, I would like to spend a few words to remember why we have this award and to whom it is attributed. This award is the most prestigious Eaap distinction. It was established to honor the memory and the legacy of André Max Leroy, a visionary leader and the first Eaap president, who strongly promoted international collaboration and excellence in livestock research. Since its creation in 1991, the award has been conferred annually at the Eaap annual meeting, and its purpose is to recognize scientists with outstanding, long-standing contribution to animal science, particularly those who work as advanced knowledge, innovation, and sustainable practice in livestock production. Candidates must be actively engaged in the Eaap work, and the selection is made by the Eaap Council and Scientific Committee. The award reflects not only scientific merit, but also deep commitment to goals of the Eaap, such as advancing animal science, supporting sustainability, and establish collaboration across Europe and beyond. Ladies and gentlemen, after this short preamble, I would like to announce you the winner and the awarded of this year. This is Antonella Baldi. The person that knows me knows that I don't really like to read all the detail, but in this case, I actually do not have to allow myself to forget any of the achievement of Antonella, and I have to read some word about her achievement. So Antonella Baldi is full professor of animal nutrition at the University of Milano since 2000. She began her career in animal science in the same university in 1987. After graduating in biological science, and has since become leading figure in the field of animal nutrition and welfare. Her research has focused in how nutrition and husbandry practice influence animal health and the quality of animal delivered product, with special emphasis in milk production. She has published nearly 200 scientific papers, and her study on vitamin, trace element, and fatty acid has helped shape our understanding in animal health and welfare. Professor Baldi has played active role within Eaap, serving on the council, contributing to study commissions, and helping to establish both a network in collaboration with the American Dairy Science Association. In recognition of her dedication, she received the Eaap Distinguished Service Award in 2019. Behind her research, she was deeply engaged in European scientific networks, including service the ECR peer review panel and leading coast initiatives on mammary gland biology. At the University of Milano, She also served as Deputy Rector for Internationalization, building global partnerships, and expanding opportunities for students and researchers. Professor Baldi's contribution extend from scientific excellence, leadership, mentoring, international collaborations. She embodied the spirit of Eaap, combining dedication to research with service to our community. Please join me to warmly welcome Professor Baldi on stage. Antonella, the stage and the audience is yours.
Thanks, Joel. I'm truly honored, proud, and really happy to receive this Leroy Award. And I would like to, I'm also happy and grateful to Eaap, and I think that my period where I served in the council was very shaping for me. And well, I would like to share with you my gratefulness for this award. Well, I believe and I know that having a trusted network of colleagues make our life easier and research better. And I think that today I will try to communicate to you some experience that I had, but also some reflection about the international cooperation originated by my research activity, of course, firstly, but also, as Joel said very well, by my last 7 years as a internationalization deputy rector of University of Milan. That is a large, comprehensive, research-intensive university. It gave me the opportunity to have a large, a broad perspective on that field. Well, I would like to address these 3 simple questions. Why international cooperation, and why now, in this global situation, is important to be reaffirmed? But how we have to address this re-envisioning, and what is really important behind, of course, the research excellence and all these things that we know very well to push forward in this moment. Well, by the way, these principles has been recently reaffirmed during the interministerial governance meeting in Brussels. You can see here the so-called Brussels statement that summarizes a long way of discussion of multilateral dialogue on this cooperation among not only the member states, but also neighboring states and other stakeholders. You can see some keywords here: togetherness, mutual trust, and the important to establish a global ethical compass in R&I, something we need to reaffirm now more than ever. So why, and equally important, how should we act on them? Okay, just one slide. Sorry, Joel, but I have to put there to remember who we are. So it seems really obvious that for us here, colleagues of the Eaap, members of one of the largest associations of animal scientists, it's obvious that we are internationalized. But I think also that it's important to know some numbers. And the numbers of Eaap as a global network is quite important to know, because we are 7,000 individual members, 900 institutes. And then we have companies and also other stakeholders join us. So that's quite important to remember, because we are strong. We must our voice, we are shout out about our opinion, our ideas. We must have an impact. And this is even more important because we are also member of a global network, that is the World Association of Animal Production, that allows us to face global challenges, like yesterday we have discussed during the livestock system of the future in the afternoon. Well, so within this framework, I would like to remember that a remarkable number of events, of conferences, workshops, of course, here is our annual conferences, but a number of satellite events joined this event, and many are co-organized with the other association. So let's now have a big focus on my experience on that. And my experience, the one I would like to stress more, was the one in biology of lactation in farm animal. Why BOLF is important? Because I think that you can see them, all of you, personal experience, a similar personal experience as I have had when I was a young visiting scientist in Cornell University, Department of Animal Science in '92, and then joined for the first time this biology of lactation in farm animals. What was this BOLF? It was a consortium of scientists working around lactation, biology, from different perspectives, different fields, a multidisciplinary group of scientists working from the basal fundamental research to the applied field, what now we should call translational research. At that time, the name was not yet invented, but we were in that line. You see in the cloud some of the topics we have addressed, and personally, I was really involved in most of these meetings you see all over the world. Just this is the map. We started in '92 in Madrid, and the last one was 1 year ago in Bern. And in the middle, other associations joined and helped in this workshop. Well, let's say just few highlights of this research, the one I was more involved. In particular, in the 90s, you see, in the 90s, one of the first biotech products was delivered. It was recombinant growth hormone called RBST. RBST was found and discovered as a tool to increase milk yield, but a further commercial use that was very discussed in Europe is not allowed, for instance. But what was important, really important, was that it gave a tremendous push to the studies on lactation biology, but not only to lactation biology per se, but also to the mechanism underpinning the mammary gland function, and especially the partitioning of nutrients toward the mammary gland that increase the milk yield, but also make us understand some of the mechanisms of lactation efficiency that still now we use in our study. So that's shaped a lot, and as you can see in these figures, this was a mammary gland of a group of, an example of a mammary gland of the group of dairy goats in lactation. The first one was treated BT. The second, this below, is not treated. You can see the difference in the shape of alveoli. The full one, same stage of lactation, are full of milk, have globular epithelial cells, while the other one are involuting. This makes us understand that mammary gland is incredibly flexible, has a hard plasticity, and this not only using this technique, but also increasing milking frequency and other milking techniques that we have experimented. So we discussed in those period what was the homoetic mechanism underpinning lactation, as Bowman and Corey said for the first time in the 80s. And this led us also to study a number of biomarkers of function of the mammary gland, but also of involution, like plasminogen activation system that I've studied during my stay in Cornell, but also later on in Vermont with Professor Politis, that was one of my dear colleagues and friends even now. And we studied a lot this system because it was, of course, an ubiquitous system. Plasminogen is cleaved to plasmin by plasminogen activators, but what is important is that this proteolysis, as you see, can be attached to the membrane, and in this way, through a receptor, and in this way, it was possible remodeling of tissue through their proteolytic activity, but also cell migration. And cell migration is important in some cases, benefits like for neutrophils and chemotaxis, as you can see in in this study, but also is associated to cancer and migration of cells. So palindrogen activators has different, of course, benefits, or otherwise is a biomarker of cancer. Well, these studies was always very much addressed during BOLFA meeting, as well the micronutrients uptake and delivery to the mammary gland. Just very quickly, I focused especially in the BOLFA meeting in Lillehammer and then in Bled on vitamin E as a golden standard of antioxidant. But what we studied was all the constellation of molecules inside the cells and on cell membrane that is able to maintain the healthy and strong production in dairy cows and in overall all the animal farm animal. What I would like to stress here is that these studies has been performed thanks to the use of these epithelial model of bovine mammary epithelial cells, and this make it possible to understand, for instance, that these micronutrients are important also to counteract some cytotoxic effect, especially from mycotoxin that, it create a big problem. Well, going on, we arrive to one of the most important and addressed studies during all the period of BOLFA meeting, because over 30 years, of course, science progress, but especially technology progress. We have omics technology that make us understand better some important role of, in this case, milk bioactive components. Milk is not only food, is also a deliverer of a lot of bioactivity, like, for instance, lactoferrin, that we studied thanks to the collaboration with Michel-Olivier Bousquet. You can see here the trafficking inside the mammary gland, and we understood very well that the lactoferrin has both protection for the neonate, but at the same time protect also mammary gland, as well as milk bioactive components, bioactive peptides that are characterized thanks to peptidomic and proteomic analysis. We have things, for instance, that they are antihypertensive function, but also in intestinal cells is able to stimulate mucus production that is protective for intestine. Finally, of course, milk lipids, and especially milk fat globule. I remember still a presentation on that, and we have contributed to this kind of work, because mammary gland epithelial cell, the apical part, has transferred to the neonate, thanks to the membrane of fat globule, that stabilize also a number of bioactive lipids that are quite important for the survival, not only for the health of the neonate. Well, just very briefly, I would like also to conclude this short narrative saying that BOLFA was important because there was a lot of spillover of projects, collaboration, like the one in COST, especially COST action, mammary gland biology, and mammary gland development function in cancer. COST is one of the oldest program of networking of Europe, and is still very important to that aim. Well, but now we say why. So it's very easy to answer to the why question, but how to answer to the how question and what question, just a little bit more complicated. So when I was thinking of that when I was in Greece, in Naxos, this was my umbrella, and I thought that the European umbrella of the knowledge of square. And not by case I was in Greece, that is in the heart of our Western philosophy culture. But by the way, I think that research, innovation, education, and societal engagement are all financed under the umbrella of our European funding, but at the same time are really interconnected. They are not silos, separate silos. We have to remember that as a scientist, of course, we are interested in RNA, but we must address also education, societal engagement, but also transfer of knowledge. Well, what we say, this is a good metaphor of how the four domains are connected, and at the heart of that, in terms of financial support. To be concrete, is Horizon Europe. Well, of course, we start with some reflection. Horizon Europe stands at the heart of European competitiveness and innovation. Now we are at a halfway point, in January 25 exactly, of the program 21-27. But we are also looking ahead to the next FP10. So there are some reflection. You can see the advantage in terms of economic value and societal benefits of this program. But at the same time, we have to underscore that this is the first call, the 25 one, that has came out and now is ongoing. I think that many of you know very well this because probably are applying. But this is the first call under the new Commission. So what is important is to understand what there is behind this call, and especially look ahead for the next framework program. Of course, we are now in the middle of that, so we have a fast look at to this number. We are mainly, as a scientist, in the cluster 6 of Pillar 2 of the competitiveness. And we see that, looking specifically at these key figures that has been presented by the Commission, we can see that the 7 destination, especially in the number 2 farm to fork, has been represented. And of course, mainly our R&I action. And if we look a little bit inside these numbers, you see that the expected grants for this 25 call are around 143. 37 are in the farm to fork with a very important budget, and this is an indication. You can see overall that this about 31% is from farm to fork. I know that many of you are involved also in the other destination, but I think that the topics of these that you probably know already are very indicative of the link of this call to the vision of agriculture and food system that has been recently published. And these are the single stage topic is enabling sustainable farming systems. We have a wall of presentation yesterday and in these days on that. Fishery and aquaculture, transforming food systems for healthy, sustainable inclusion, and then coming back to the topic on international cooperation, there are some target international cooperation, especially to Africa. And 40%, as you have read before, of all these topics required international cooperation. So this is a strong message that comes out from the Commission about the openness, at the same time safeguarding our security, of course, but the openness is still at the basis of our research. There is another important point that I would like to address with you today, and this is the change of paradigm that these 21-27 programs point out. The change of paradigm was the multi-actor approach. The multi-actor approach is a different kind of approach to the research, where all the stakeholders, the actors, start since the beginning to collaborate. So we do not make research for, but we make research with all the stakeholders, all the actors involved. We create an ecosystem where there are individual researchers, citizens, advisors, but there are also, of course, farmers, associations, companies, and, of course, also policymakers. All this bulk of different actors create an ecosystem that it seems complex to manage. In fact, the direction is to have large programs, large projects, a little bit complicated, but the co-creation and sharing of knowledge among different types of actors is fundamental. And also tackling together global societal challenges is important to involve associations like Eaap, like ETF, since the beginning. But at the same time, all the complex projects need also a strong management, and especially considering the use of new technologies, AI, bioeconomics technology, new innovative technology. We feel that it's important to have the so-called orchestrator. What is an orchestrator? If you look at the economic field, the orchestrator is one or several experts that make the colloquia among these so different stakeholders always update and use the right words to speak with the right person. And communication became fundamental in this case. So orchestrator is a new figure of professionist, and we have to think about that later on when I will speak of union of skills. That, of course, this was pillar 2, but remember that we are in pillar 1. Pillar 1 are the bottom-up, so top-down and bottom-up match. And I would say that you know very well the Marie Stolowska reaction, as well the ERC. And I think that I have no time, of course, to enter into much in that, but you know that this year, especially Marie Curie, but also ERC, has been pushed ahead with this famous speech of Ursula von der Leyen in Sorbonne. I don't know if there are some Sorbonne colleagues or someone who was there, but it was really a flamboyant, a very inspiring speech about to attract the best talent and to Europe, and also how to finance them, but also include them and valorize their research. Well, I would like to say a few words about that, because of course we are all agree about that. Marie Curie, by the way, has been always an ERC, the right project to attract young or more senior researchers. But go back to my experience. I see here in the room my colleagues Elga and Fabrizio, some there, and we would like to speak about 1 minute to the experience of this European Joint Doctorate on Molecular Animal Nutrition. This was launched in 2018 and was coordinated by David Eckersall. You see here the first meeting. Maybe you see some known face. Well, it's me here. Then Armand Sanchez from Spain. Fabrizio Ceciliani is my colleague that was the PI for the University of Milan. And then Elga Sauerwein, the coordinated David S. Eckersall. I never know how to pronounce it, but I think Eckersall is the correct one. Then Muriel Bonnet, that was not in the picture, but from IRAE, was as well involved. And then, of course, Giovanni Savoini, Vladimir from Zagreb, Chak, I think is the second name, and Maureen. But what was more important are all this number of young researchers behind. They come, of course, from Italy, Spain, but from India, Tamil, for instance, from Iran, Arash, and then from Philippine Iron, that is here somewhere as well. And then there is Xian from Tamil, and then Gabriela and Rafaela from Brazil and Costa Rica. All why I nominate each one by name, because it's good to say that we want to attract, but we must manage with this attraction. And I tell you that in 6-7 years of vice rector of international engineering, every day I have to manage with visa, not with flamboyant speech, but to visa, to permit to stay, to find, of course, the location where they can live, and to manage with bank account. These are the real problems. So if we do not solve also this problem, we can say all the beautiful words, what we want, we can put also a lot of money. We select very good researchers, but they never come, or they come too late. So I want to send this message because this is my personal experience, and I say that this is quite important to be concretely underlined. So to finish this first part, what next? How much? Okay, what next? So next is the New Horizon Europe. Well, of course, there is a draft that is published on 14th of July. What we see is that very structured, 4 pillars: excellence of science, competitiveness and society, innovation, and European research area, infrastructure that include also the widening program that was very, very efficient and effective. Is a self-standing, connected to the European competitiveness. And of course, this is the point about the future. What do you prefer? Do you prefer large difficult to manage and very impactful in the value chain consortia, or also some medium, large-scale projects where some new technologies, new ideas can come up. Of course, we have the ERC that is bottom-up, but I think that some small space for middle-size projects should be important for us. And then education. What I want to say is that in the next framework programs, education and transfer and society will be much, much more financed. And so this, we come back to my umbrella in 5 minutes. We have to speak about that. Education, societal engagement, transfer to society. Well, Europe made a big push forward in this direction over the past 5 years because they published the strategy for higher education, and especially they financed one of the most visionary and impactful transformative program from the Barcelona 30 years ago pathway, that is the European University Initiative. Right now, they have financed 7 consortia called alliances with about 570 universities in Europe joined together. For what? For what? For pushing forward a new kind, a new type of university, new European joint programs, European degree, but also initiatives that merge researchers, that make mobility more easy of our students, but also create the basis for a long-standing transnational collaboration. And in these frameworks, Europe has published, Commission has published also the Union of Skills. The Union of Skills are a specific long visionary project that wants to add to the traditional, would say, degree, also a number of more specific courses, of more target educational pathway to skill and reskill professionals, but also our students. And this is an example of how many European universities are there. And this is, I would like just to show the For You Plus University Alliance, where University of Milan is engaged around 4 flagships that are our thematic disciplines: health, Europeanism, digitalization, and environment transition. I think that this example is one of the 7th, but give you the idea of the importance, the strength, and engagement that we have in this new form of education. Now, let's go back to us. What is important for us? We have listened yesterday, the young farmer. I quote some of her points, key messages. They need to address technical complexity of livestock farming. They need to be prepared to the diversity of challenges across territories. They need that there is a real prospect to knowledge, generate a new generation. And this is also passed through education, through skilling and reskilling, in a very fast and direct way, because they are working. They are young, clever, they need reskilling and skilling very frequently. And so this kind of topics, like I have listed here, new technologies, new generation of expert, remember the orchestrator I mentioned before, but also entrepreneurship, information, ethics in life science, all these things must be delivered other than the classical, traditional topics, to have, of course, the livestock system of the future. And that takes us to the very last part of my speech, 2 minutes, 3 minutes, 2 minutes. That I go back to principles, values in international cooperation. You can read it. These are values that we have always to remember when we work. And I would like also to stress that we have on that, and I remind you to that, a special number of, there is a special network, because if we feel that academic freedom is at risk, we have to know that there are a number of networks that create opportunity for colleagues where academic freedom is at risk, where for reason for war or political reason, they cannot be able to make their work as a teacher of research. So we are quite involved in this scholars risk network, but also this issue will be addressed by the next Animal Frontiers journal issue that is on access to animal science from multiple perspectives. It will focus on diversity, equity, and inclusion, considering diverse students in the classrooms, for instance, of course, addressing the gender balance in agriculture and also in career advancement, and also was most important, some papers that will be published on the Global South. Yesterday we have heard some colleagues asking, but what can we do? What you as European model of livestock system can give to us in our specific situation. And in these papers, there will be, of course, highlight the problems, but also possible solution, the needs of smallholder farmers and marginalized communities as crucial mean for ensuring equitable growth in livestock sector has been clearly addressed. And then let's come back to us, to our journal, because if we speak of open science, that was one of the themes that we see in the previous slide, we have to speak also of research excellence, the way we evaluate, the way we include at international levels all the excellent researchers in the world, and how we valorize our knowledge. And I think our journals, especially Animal Open Space is the last one, exiting, is quite addressing this point. And last but not least, I would like, I think I am in time, to thank all my colleagues, to thank Eaap, to thank my Italian Association of Animal Science, and to thank all this group of people, Luciano, Carlotta, Raffaella, Luciana, and others that you can see here in the picture. And finally, my family for patience during this year. My son and my husband is somewhere here anyway. Thanks a lot for hearing me.
Thank you very much, Antonella. I'm sure there is a lot of questions from the audience. We have a very restricted time, but I would like to give you the opportunity to raise some questions to Antonella. Please raise your hand if you have any question. Oh, please, yep. There should be a micro. Oh, perfect.
Antonella, I'm here. First of all, congratulations for a well-deserved award. And I really liked your introduction about international collaboration, which I think is crucial. And I think for the young scientists here, it's the opportunity to establish their network. But at the same time, we know that research is also competitive. So how do we match that collaboration with competitiveness? Because in European consortia, it's very competitive. So we compete with our best friends sometimes. So how do we match competitiveness and collaboration?
Okay, you mean on the European University Initiative? Or
in general, I mean, young scientists here, they will compete for positions. In European projects, we compete in different consortia with very good friends. So how do we maintain that balance between being good friends, being good colleagues, and being competitive at the same time?
Well, the first point is excellence. So I think that having been in the panel of evaluators since 20 years of many programs, I really have a blind approach. So let's look at the project. Let's look at the project. Then you look at the CV as well, but you must look at the project. If you find an innovative, a true innovative idea, that must go on. So this is our, I would say, compass. It was my compass over the years. This is a piece of story, and this is on research. Another piece of story is everything else that are education, mobility, capacity building project, partnership, strategic partnership. What do you mean with strategic partnership? Strategic partnership is something that impacts on research, on education, on your life, on the life of everybody around you, and have also society impact. So this is another part of the story. But as I show, we are under the same umbrella. So let's go for innovation and excellence when you have two select a candidate, of course, push forward a project during your evaluation work as a scientist, a researcher. But at the same time, remember always that you are part of the community. And there are many, many other situations where you can really impact in the inclusion and in collaboration, in more, I appreciated a lot the question that yesterday afternoon raised from colleagues from Africa, and they say, okay, these are your model, but of course this not fits for us many times. And again, what are you doing in that direction? The blanket is one, so we have to take care of all the pieces of this story. So I really think that competitiveness and collaboration can coexist.
Okay, thank you.
Thank you very much. One last question to Antonella. If not, actually, Antonella, I had one. Can you? I know we are a bit late, but you are so important. Can you give to the young scientists in this audience, PhD and postdoc, maybe one single take-off message? Because I see here in the front we have Marcello, Jean-François Oquette, we have Pinotti. For them, it's too late. No, you cannot save them. It's
no,
too late.
But if you are the young research, I'm happy.
I know I'm very unpolite, I know. But there is a lot of young scientists here. And can you try to give maybe one key word, one message that they have to bring back home?
Never give up. Oh.
Pleasure and honor to come for you. But Antonella, you cannot leave now because I know many secrets of the people, and one of the secrets I knew from you is today is your birthday. So I will ask the whole audience to make a little wish for her. Antonella, happy birthday to you. Happy birthday to you. Happy birthday, dear Antonella. Happy birthday to you.
Thanks a lot. I just want to. I spent most of my birthday at the Eaap, so I think I deserve it. Thanks a lot.
You're welcome. Ciao. We organized the whole conference around this event. We can now go on with the second part of this morning. Actually, I would like to start thanking and acknowledge all the people that make this conference a success, and especially would like to thank the Agricultural Ministry of Austria and the NTO. Is nachhaltige Tierhaltung Österreich. Does it mean for the not German speaking? Is sustainable animal production system from Austria, and of course the local PCO. They really deserve a big applause. I also would like to thank all our sponsors, especially Platinum sponsor, C-Lock and Illumina, our golden sponsor, TechnoSense, and the silver sponsors, American Dairy Science Association, American Society for Animal Science, and Alma Marketing. All our bronze sponsors, and all the other sponsors that actually support our activity. Many of them, they have stand here, so please join them, look at their activity. They are for sure very important for supporting our research activities. Many thanks also to the Industry Club. You see many of them are listed in these 2 pages, and also there a lot of them have actually stand outside. Please have a look at their activities. I also want to, again, to thank the local organizing committee. Here there is a few names of the really person that's put a lot of energy and time. We arrive here on Sunday, on Saturday, and everything is set. And it's actually thanks to these people that really spend many days and hours of working for us. So from the Federal Ministry, I want to thank Josef and Julia. From the NTE, Joanna, Roland, Stephanie, and Reinhard. From the LT Tirol, Christian, and from Zuchtdata, Christa. Thank you very much for your excellent work. Of course, for the scientific part, for organizing all the session, for managing the abstract, we really have to ask the activity on the EAP, the work of the council, and here you can see all the representatives, and for the scientific part, the scientific committee. So thank you very much. I cannot mention all of them, but you know by now all these persons, they are the president of the different commission, our vice president, Sam de Campanier, and also the secretary, Anne Spolder. Thank you very much for your work. We already heard a couple of times now about the different activity that EAP has. One is networking. I think that's sitting all together here, sharing data, sharing knowledge. This is actually a big part, a large part of our activity. But the second one is, of course, dissemination channel. And please, Antonella already mentioned the large activity that we have through our journal, animal family journals. You have seen, and you will see during the holiday, people with an animal t-shirt. Can these people just stand up, please? Thank you very much. You are representing our journal, and I really encourage all the young people that still don't know this journal, that don't know these people, to join them, to raise questions, to challenge them with questions. And actually, you have really, if you are a member of the EAP, you have to feel that this journal is representing you. So I really encourage you, before submitting to other journals, to submit to animal family journals. This journal belongs to the EAP, to the British Society of Animal Science and the INRAE, but since this year we also have associate party. I really hope that many other research institute or federation will join. So at the moment we have Agroscope, Wageningen, IRTA that join, but we are looking forward to have other associate party in the future. I also wanted to mention the Animal Frontiers, and other dissemination channel we are using is actually the EAP newsletter. Is received by more than 9,000 people, is more than 3,000 downloads every second week, so I'm sure that our newsletter is very well read. And also I wanted to thank all the young people that are helping us and actually making the translation in all this language. I think there is few newsletters are so spread. And this is also for our industry club, for our sponsor, a very nice way to be promoted all around the world. And of course, we have here on the front line, Federica, you have seen we are very active in all the social media. So do not hesitate, if you're taking picture, making video, also to tag the EAP, we will repost it, and this is also part of disseminating our news. For sure, scientific articles are the main way, but what not to try to touch much more people and a broader audience also through our different social media. I also wanted to mention in which project EAP is involved, and I also encourage, we have now different calls like Horizon calls, to take into account and to consider also EAP as a dissemination partner. So do not hesitate to write to me, to Andrea Rosati, to ask what EAP can build and do in your consortium in order to push dissemination. I know there is a lot of projects that are going on. Please, EAP can really contribute. There is no other better channel with a so high visibility than the EAP, and we can really contribute to your project. And I will now like to move on the award ceremony and on Distinguished Service Award. As you can read, the Distinguished Service Award is an award that is annually recognized on EAP member for exceptional service and for a very deep impact in animal science. It's highlighting contribution to collaboration, supporting young scientists, knowledge exchange, innovation, and sustainability. The awardees embody really EAP mission, advancing science, connecting livestock community internationally, and of course supporting all this activity. And this year, we have 3 persons that will receive this award. And I would like to start with the first one, that is Isabelle Cassasius. Isabelle has been president of the EAP in the period 2020-2024, so putting the expectation threshold very hard, and that's making my duty very hard. So thank you for, for your excellent work, Isabelle. Before, she has been a member of the EAP Council, representing important Mediterranean countries. She has a long contributed on the EAP through leadership in the Mediterranean workshop group, coordinating symposia, training course, and initiatives such as Young Club. She's a veterinarian with a PhD from the University of Zaragoza. She is currently a researcher at the Cheetah, Oregon, focusing on extensive ruminant production system, integrating genotype, nutrition, management, and sustainability. She leads research at the Cheetah Farm and teaches postgraduate and extension courses, actively engaged in international networks like FAO, ATF, CHIEM, and she also dedicates many efforts for foster young scientists' participation on the EAP activity. So, Isabelle, please join me on stage. Isabelle, it's a big honor to attribute you. I think there is a picture that we have to take. Thank you.
Thanks very much, Joel. Thanks very much for your kind words, and I would like to thank very much the EAP for giving me this award. It's been an honor and a pleasure to give whatever service I've been able to give in these years, and I wish to continue, of course, in the following years. So I can only encourage the room, and especially the young scientists, to engage in this kind of commitment to our community, because it's really very rewarding at many professional and personal levels. I would also like to share this recognition with all the good friends and colleagues that I've had the opportunity to work with during these years, in the commissions, in the council, at the EAP Secretariat, and at many other levels, and also to those who have held the fort back home at CITA when I was not at my desk. So thanks very much to you all.
The second award goes to Jean-François Auquet. He was born in Clermont-Ferrand in France. He's a prominent researcher in muscle biology and meat science. He holds a degree in agronomy, specialized in animal nutrition, endocrinology, metabolism, and meat science. Since 1991, he has been a research scientist in the INRAE, published over 220 scientific papers, and securing more than 8 million in grants. He has mentored countless students, leading muscle growth and metabolism groups, is coordinating large French and EU projects, and contributed to consumer-oriented beef granting system. Active in EAP, he has held leadership role, co-editing scientific book, service as an editor-chief in meat and meat production, and finally, and made the most important, he has the main local organizer of a very successful EAP meeting in 2023 in Lyon. Jean-François, please, can you join me on the stage?
Thank you very much. It's a great honor and a great pleasure for me to receive this honor. So I've been working for EAP for almost 25 years. I was secretary, vice president, and president of the Cattle Commission. This is the reason why I have a tie with cows. So I was also organizer of the main congress in Lyon 2 years ago with 2,200 people. So I would like to thank very much all the colleagues, all the people who work with me to organize this meeting, including my wife, who is here in the room. I would like also to thank very much all my colleagues of the French Association for Animal Production. So it was really a collective work with all members of the Cattle Commission, all members of the French Association for Animal Production, and all my French colleagues. So thanks a lot to all of them.
And the last award goes to Marcello Mele. He's originally from La Spezia in Italy. He's full professor of animal science at the University of Pisa, where he's also served as a board of director. After studying agricultural science in Pisa and a PhD in Perugia, his research has focused on milk and meat quality, rumen metabolism, and feeding strategy to improve efficiency and reduce environment impact in ruminant. For over a decade, he had advanced agroforestry system in collaboration with international partners, integrating them with pressure livestock farming. Deeply engaged with farmer and industry, he has held major leadership roles and also editor-in-chief. His activity as editor-in-chief was crucial for the successful Italian Journal of Animal Science. He was also the main local organizer of the 2024 Eaap annual meeting in Florence, and recently he was also elected as a president of ASPA, the Italian Association of Animal Science. So please, Marcello, join me on stage.
Thank you. I'm very happy and proud to receive this award, and I'm very grateful to the Eaap Council and also to all the Eaap community. And more than 25 years ago, when I participated to my first Eaap Congress in Zurich, I can't imagine that after 25 years I received this award. And during these last 25 years, I participated to a lot of Congress, and I have also the honor to organize last year an annual Congress. It was a very challenging activity, but I was very happy about the success of the Congress, and I can say that in the last 25 years I learned a lot participating to the Eaap Congress, and I encourage all the young people to actively participate to the Eaap Congress, because it's a very great opportunity for the young people. Thank you very much.
And the next award is also a very important award. It's the Young Scientist Award. As you can read, it's recognizing researchers with outstanding scientific contribution on the Eaap. But I will not present this award. Actually, I will give the stage to two of my most brilliant colleagues on the Eaap, representing the young club of the Eaap. So Julia, Jana, can you join me on stage? Jana, the stage is yours.
So, first of all, I would like to thank you, Joël, for giving us this opportunity to present this prestigious award. The Young Scientist Award of the Eaap is dedicated to recognizing the next generation of leaders in our community. It is awarded to young researchers who have demonstrated outstanding scientific contribution and a strong commitment to the goals of the Eaap. Through their innovative work, active participation in our meeting, and engagement in the Eaap Commission and networks, these young scientists are helping to shape the future of animal science. This award celebrates not only their achievements so far, but also the promise they hold for advancing research, sustainability, and collaboration in the years to come. This year, the Eaap received around 10 applications, and we have 3 candidates that have been nominated for this Young Scientist Award.
Yes, so thank you. I'll present the 3 candidates. So the first candidate is Samantha Mekochi from the University of Tuscia Viterbo, where she's a fixed-term researcher. She specializes in molecular genetics and extracellular vesicles, particularly those derived from milk. She earned her PhD at the University of Perugia, and now she's involved. Now you can also see her. And now she's involved in several international projects actively contributes to task forces and scientific associations and has published more than 35 papers. And I think all the candidates deserve an applause before we figure out which one won. The second candidate is Giovanni Niero from University of Padova. So he's an assistant professor there, and he also earned his PhD at the University of Padova in animal and food science after a research stay at ETH Zurich. His research focuses on milk and dairy product quality, developing innovative and low-cost technologies to analyze milk composition on a large scale. He has led several international projects as principal investigator, published more than 50 papers, and is an active member of the Eaap community with 20 contributions and an ongoing role as session chair. And the last candidate is Mutian Yu from ETH Zurich. So he earned his PhD in animal biology from UC Davis and has served as a tenure-track assistant professor of animal nutrition at the University of Pennsylvania and as a data scientist at Farmers Business Network in the US. He is currently a tenure-track assistant professor of animal nutrition at ETH Zurich in Switzerland, and his research focuses on animal nutrition, physiology and metabolism, as well as statistical modeling and data science, and he has authored more than 40 publications and led several research projects as principal investigator. So now we have to figure out who won. So Julia has busta, which is an Italian word I've learned recently, the envelope. And it is with our great pleasure to announce that the winner of this year's Young Scientist Award is
Dr. Giovanni Niero. So, Giovanni was recognized by the Commission as a prominent member of our community with extensive contributions to the Eaap. Beyond his achievements, he is regarded by the scientific community as a humble, cheerful, and generous colleague and a mentor to many young students. So please join me warmly congratulating Dr. Giovanni Niero for winning this Young Scientist Award.
Thank you all. Good morning. Just 30 seconds for some important acknowledgements. So, first of all, let me thank Joël Berard, President of EAP, all the EAP organization, and as well as the Young EAP Committee for this highly appreciated and highly distinguished award. Secondly, and importantly, I would like to thank my research group, both the young part, which is here today, and as well as my research leader, who is here in this room. So without their support, it will be impossible to reach such an important goal and prize, of course. Just a more personal note, I would like to thank my family, my partner, my friends, for having supported me during these quite long years, I would say, of research. And finally, really, last acknowledgement is for you all. So we are here to celebrate the EAP annual meeting, and without you, this meeting would not have been possible. This prize would not have been possible, so thank you all so much. And so let me conclude by saying long life to EAP, enjoy the Congress, and this applause is for you. Thank you.
We're coming now to the last award that we want to attribute. The William Schaumann Stephen Award goes to Charles Hernandez Banque. If he's here, can just stand up, please. The Animal Journal Award goes to Theodor Jove from Spain. For the Novus Award, can I invite you on the stage? And the Novus Award goes to Martin Julius Cote from Belgium. I hope he's here. Unfortunately not. But if you want to, please say some words about you.
Yeah, thanks so much for this great honor. Thanks to my research group back at KU Leuven and all my colleagues and collaborators that helped me with my work so far. And thanks a lot also to Novus for this great honor and allowing me to be part of the exchange between EAP and ADSA and going to the ADSA conference this year in the US.
Thank you. Sorry, I didn't notice that you were behind me. You're welcome. And the last is the early career competition. Let's go to Pedro Ceseglo Forzola. Oh, is he here?
So hello everyone. I'm glad to represent the Awardee Group, which is a French-based company specialized in mineral nutrition. Yesterday we had the opportunity to sponsor the early career competition for innovative approach in pig and poultry production. We had 7 excellent presentations, and I'm glad to give this award to Pedro, which gave the best presentation according to our scoring methodology. So I'm very glad to give you this award. You will be granted this certificate and also a free registration for next year EAP. Congrats again.
And also here, I would like finally to mention that there is many scholarships that are granted by national association, and here are listed in this last slide. And with that, I would like to wish you a very successful meeting in Innsbruck. We are a bit late. I'm really take all responsibility of that. I'm Swiss, but unfortunately, I'm not so so Swiss on this aspect. My Italian DNA is still dominant compared to my past. And we can now move on the very, very exciting plenary session that is waiting for us. I do not want to anticipate too much. I think that all of you had the chance to read the book. And we decided this year actually to have a different perspective, to give you a glance of history of animal production, how is important and which role they have, the animal production have played in human civilization. Few minutes, we are preparing. And it is for me a big honor and a pleasure to invite on stage the first speaker of the morning is Mike Ben-Dor from Israel. Mike is a paleoanthropologist researching and publishing in association between diet and human evolution during the Paleolithic. He has a PhD in archaeology from the University of Tel Aviv, a bachelor on economics from Hebrew University, and MBA on Fontainebleau in France. He's running 2 blogs, and he's also writer of different books. So join me in applause for welcoming our first speaker of the morning, Mike. The stage is yours. Thank you very much. You just use the control with green, you can move on the next.
First of all, I would like to thank Joel and Andrea for inviting me. I have half an hour to convince you that we are all carnivores. Biologically speaking, we don't wake up in the morning and go hunting. And so I will start a story. I will start the story with human evolution until, that's my part, until we reach agriculture. So Gerard Diamond wrote a paper in 1999 saying that agriculture was the worst mistake in the history of the human race. And I'll try to show that it's not a mistake. We simply had no choice. We actually were going to agriculture screaming and kicking, and we are still kicking and screaming. So we'll start at human evolution. We can start anywhere, you know, from a microbe, but we will start with the common ancestor of us and the chimpanzee 7 million years ago, which got their food from the trees in the form of fruits and leaves. And these fruits, by the way, were very fibrous fruits. So researchers who follow chimpanzees tried to eat the fruits, they couldn't. The fruits that the chimpanzees eat are not domesticated. And this will become important later on in my lecture. Anyway, about 5 to 6 million years ago, the landscape started to open because the climate became a little drier, and we find a hominin, still not homo, but a hominin, that looks very much like a chimpanzee who is walking upright. So the same brain size, the same facial features, but really just walking upright so he can manage a little better on going on the soil. And we think that he fed mainly on tubers. So instead of fruits, he sort of dug tubers from the soil. The first time we see a Homo, and the definition will be clear to you, is about 2.6 million years. And at that time, we see already stone tools and bones in archaeological sites. And you see marks on the bones of the stone tools that were used to remove the flesh from the bones and to actually break the bone to get the marrow. And we see on the stone tools signs of cutting flesh. So there's no argument that we started our interaction with meat about 2.63 million years ago. And if you look at the bottom, the chart at the bottom, it will be clear why. And it shows the level of biomass from animal that's edible in savannas compared to rainforests. So really the food was just available and waiting for this change from rainforests to savannas had an opportunity for somebody who could take advantage of that food. But the real first hunter, it's quite accepted, although, you know, in science there's always debates, so I won't go into all the debates, otherwise I will never finish. The real hunter, and there is some debate, but not much debate about it, was Homo erectus. Homo erectus was the most successful human species, lasting for about 1.7 million years. And compared to his predecessor, he was longer, taller, and he was more adapted to running. Now, you don't run to get plants. They don't escape. So it's quite obvious, and you can also see it from the site, from the archaeological site, the amount of bones, especially bones of very large animals, like elephants. So it was clear that he became a hunter. And his main source of calories were animals. Only 300,000 years ago, and I'm saying only, for you it sounds like a long time, but in the context of human evolution, it's not that long. If you start at 2.5 million, 2.6 million, Homo sapiens arrived into the scene only 300,000 years ago. And if you compare it to Homo erectus, there is the main difference is in the size of the brain. So if Homo erectus had 900 to 1100 cc brain, humans had 1400 cc brains. So about 50% larger brain, and their physique was lighter, although they were taller. And you see in the archaeological sites, you see a wider range of prey sizes. So not only large, or not mainly large, but also some medium size. And by medium size, I mean buffalo, which is about a ton at that time. And also some smaller antelopes. Now here I can say only, I'm saying only 10,000 years ago, we became farmers. And this is 0.4% of human evolution. So less than 1% of human evolution, we are farmers. And this is what led me to choose a way to reconstruct our nutrition by looking at the body, because the body, remember, the body doesn't change the metabolism, the genetics, the morphology, don't change in a matter of thousands of years. They take tens of thousands, hundreds of thousands of years to change. We did go through some adaptations since becoming farmers, like lactose late in life, etc. But most of the structures in the body, as you will see, I wrote a paper with about 27 pieces of evidence. I will only show you 5 here, because of the time, of course. I will pass through that one. And my conclusion after doing that is that humans, throughout the revolution, were carnivores that specialized in hunting large and fat prey. And I will go to the fat part of it quickly. So let's start with the first of the 5 sort of pieces of evidence that I want to show here. This is comparative anatomy. So we compare the cornea of the chimpanzee with the cornea of Homo sapiens, and you can immediately see that the chewing system of the chimpanzee is much, much more robust and bigger. The reason is that they have to grind fiber. So you grind the fiber to prepare it for the stomach to increase the contact area with the bacteria, and the bacteria is doing the fermentation. This is, of course, you know it from cows and other animals. This is how they get their energy. So most of the energy actually the chimpanzee get, and not many people know that, is actually from fiber, because the fruit is fibrous and the leaves are fibrous. So the chewing is completely, in humans, you can see the receding of the jaws and a very small chewing system. And if you look at the stomach or the gut, you see the same, the mirror picture of that. So if you compare the vessel that is used for this fermentation, the colon or the large intestines, you will see that we have large intestines that are only 1/5 the size of a chimpanzee. On the other hand, we have small intestines that are longer by about 50% than a chimpanzee. So small intestines is where the protein and the fat get absorbed. So we moved away from extracting energy from plants, because most plants in nature have a lot of fiber. Only domesticated, actually, you can see the domestication of plants as one big enterprise to remove fiber. You take, for instance, grains, so we can use the endosperm by physically removing the fiber. So this is what humans did when we became carnivores. We did not have a need for such a big vessel to deal with the fiber and to get energy from fiber. If we go to the stomach of humans is very, very acidic compared to other animals. Actually, it's almost the most acidic stomach that exists. And it's very much like the acidity that scavengers have. So one of the reasons to have high acidity is to take care of pathogens. And of course, scavengers face much higher load of pathogens because the meat stays longer in open air. And humans, the author of this paper writes that humans were scavengers, it looks like. But she doesn't know much about how humans hunt. Humans, unlike other carnivores, don't eat the prey where they hunt it. They actually butcher it, take it to a central place where the family went, or wait for it, and then they consume it, and if it's large enough, they will consume it over a week or even a month, depends on size of the animal. So this is really, and by the way, it's very energy expensive to have high acidity and to have the walls of the stomach to tolerate this kind of acidity. You have to replace the cells in the stomach, the internal cells, every few days just to deal with that. So if we didn't need it, it would never have evolved. Another interesting area where we come into the pattern of carnivores is in weaning. We wean babies in 2.5 years, while chimpanzee wean babies 4 and 7 years. So it takes, and if you think about it, it makes a lot of sense, because chimpanzees' babies feed on milk, and then they have to move to fiber. Completely different source of food. So the adjustment takes much longer. While humans move from one form of protein and fat to another form of protein and fat, which is not that far away from each other, so it takes a shorter time to get adjusted to. Another area where we fall in the carnivore pattern is insulin resistance. Insulin is there to transfer glucose to the cell. Well, if you're a carnivore, you don't want that to happen because you need the little sugar that you have in your blood for emergencies. So carnivores have very high insulin resistance. And today, this is something that started to change with agriculture. So if you look at farmers, they have lower insulin resistance than herders. But still, humans initially had very high insulin resistance. Again, a carnivore pattern. The last, but of course not least, is the structure of fat cells. Again, we fall straight into the carnivore pattern. Carnivores have many small fat cells, while omnivores have fewer larger fat cells. And the authors of this paper, I just read a small quote from that. These figures suggest that the energy metabolism of humans is adapted to a diet in which lipids and protein, rather than carbohydrates, make a major contribution to the energy supply. That was and this is a summary that I have in the paper of all the evidence. On the left side, you have Homo erectus, and on the right side, Homo sapiens, and then Homo sapiens 50,000 years ago, what we call the Upper Paleolithic, which I'll discuss in a minute. Now, why, if it was so nice and we are so well adapted to become a carnivore, why all of a sudden we find ourselves in agriculture domesticating plants so we can consume them? And the reason that I could find was a declining size of prey. And evolution in general, if you want to understand evolution, you have to understand what was the environmental change that we had to adapt to, and what were the limitations to our adaptations, because theoretically speaking, there are infinite ways to adapt to a situation. But why did humans adapt in a certain way? And the answer is the protein constraint. Unlike long-established carnivores like lions and wolves, we can only metabolize to energy about 35% of the calories as protein. The reason is that when you metabolize it to energy, you get, as a byproduct, you get nitrogen. Nitrogen is in the blood is toxic. So we have to remove the nitrogen, And the way the body removes it, everybody, is by the liver turning the nitrogen into urea, and the kidneys removing the urea, which is called urination. Now, long-established carnivores can do 80% of their calories from, actually they have to have a lot of protein. If you have a cat, feed it a lot of protein because it needs a lot of protein. But humans actually had to find non-protein sources for 60-65% of their calories. And being hunters, the most efficient source of calories, non-protein calories, was fat. And indeed, in the archaeological record, and also in recent hunter-gatherers, when you ask them, and when you look at their behavior, you see that actually they target fat. They don't target meat. They go after where they find fat. There's evidence of hunter-gatherers in Australia, for instance, hunting, checking for fat, and if the animal is not fat enough, they just go away, leave it like that. So the first evidence for selecting fat is the size of the animals, because it so happens that large animals have more fat as a percentage of the calories in their body. Not, of course, they have more fat because they're larger, but again, they have more fat as a percentage. So that allows, if you hunt a large prey, you can use most of the protein of that prey because you have enough fat for that. Another thing that you find in archaeological sites is that humans hunted what's called prime adults. So not the weak, not the old, not the young, but the prime adult. And if you think for a predator, this is a crazy strategy, because the prime adults are in the best conditions, they are smarter, they have enough experience, they evade more quicker. So really, if you look at wolves, wolves hunt the young and the old and the weak. Human actually went after, and this is a costly energy, from an energetic point of view, is a costly strategy, but that can only be explained by the fact that they were looking for the fat. Another thing that you find in archaeological sites is that they used to take, when they butcher, after they butchered the animal, they took the fattest parts and the bones that contain most of the marrow, and they left other parts and just didn't bother to carry them to the central site. So the behavior is very clear of fat targeting. Now, what happened is that the prey size started to diminish. And this has started in Africa quite early. I won't go into detail, I don't think I have the time. In the Levant, we did a study. So in the Acheulean, which is 1.5 million years ago in the Levant, most of the animals were elephants. Most of the animals in archaeological sites were elephants. Then, when Homo sapiens came along, most of the animals are, elephants are gone, by the way, in the Levant, no elephants whatsoever. And you find mainly bison size, so buffalo size, a ton, 900 kilo animals, were the main animals, although you can find other animals as well. And then when you go to the last period, which is called the Upper Paleolithic, you find that gazelle, a 25 kilo animal, became the most dominant animal in the site. So you see a prey size decline. And the most visible phenomena of prey size decline is called the late Quaternary megafaunal extinction. This has started accelerating the pace of large prey decline about 50, 60,000 years ago. It's quite, again, still a little bit debated, but I think coming more and more into the consensus that humans were responsible for that. That humans, by seeking the larger animals, actually caused their extinction. So if you go to the largest one, 40 out of 48 species went extinct in this period. And not the same rate, but the same trend is happening in other animals, large animals, but not in small animals. And it's global, not at the same time. For instance, in Australia, it started 60,000 years ago when humans came to Australia. In America, it started about 15,000 years ago when humans came to America. So this is one of the arguments of the people who say that humans were responsible for it, is the actual association, temporal association, between human arrivals and the extinction of large animals. So this is where we talk about evolution, and here we talk about cultural evolution. We don't talk about physiological evolution at this stage. We're still Homo sapiens. But the cultural evolution, you need to have adaptation to environmental. So this is the environmental cause, coupled with the protein constraint, lead us to a solution that is consumption more and more plants. But since plants don't provide the same energy return as animals, in the end, you had to create agriculture. And they domesticated animals. By the way, Darwin already said that animals were domesticated to have more fat. And plants. So domesticating the plants allowed the energetic return because it's more concentrated in one area and it's better return, energetic return, and the domestication of animals brought the fat back because these animals didn't have to escape, right? So they could afford to accumulate more fat. So really, agriculture is a solution to a carnivore whose source of food start to diminish. And this is why today still in a supermarket, most of us stop at the meat section. And with that, I will finish. Thank you very much.
Thank you very much for this great presentation. Actually, we are a bit running out of the time, and we will have, at the end of the plenary session, a podium discussion. So please keep your question for later. I'm sure that we will have very interesting debate at the end of this plenary session. I would like now to invite on stage our second speaker, Gregor Larson from United Kingdom. He's professor of evolutionary genomics at the School of Archaeology and director of the Wellcome Trust Paleogenomics and Bioarchaeology Research Network at the Oxford University. His research interests include evolutionary genomes, ancient DNA, domestication, human and animal dispersal, and phylogenetics. So, Gerd, thank you very much, and the stage is yours.
Thank you very much. I can't tell you what a privilege it is. I've never been to the 76th edition of any meeting ever, so this is a real thrill. My only disappointment is that I'm not receiving a prize of any kind, which I feel like everybody else has got one. So, allow me to present a slightly alternative view from that presentation, to do more with the way that we perceive our own superiority and our own history and the way that everything has come. When I was first invited to give a talk, I said, well, what would you like me to speak about? We work on a lot of different things in our lab, and they said, give a presentation about how human beings modified animals for their purposes. I was like, oh, okay. It's sort of the opposite of what we do, and it's sort of a different perspective than what we usually have, and embedded within this is a concept of very deliberate, intentional, top-down, humans are smart, we do this for a reason. And so one of the interesting things is that I received a paper to review recently, and this kind of perspective of how humans are brilliant and this is what we do all the time comes from a quote like this, where one of the most significant cultural innovations of humanity was the domestication of plants and animals. It's presented this way. It's an innovation. It's something we do deliberately. We have a problem, we solve it. This is what humans do. Even more recently, you may know this gentleman, Daniel Lieberman. He's at Harvard, which means that he's very important. He's a paleoanthropologist. People pay attention to what he says, and he was on a podcast recently where he even went one step further and presented it as agriculture was invented only 600 generations ago, highlighting the relatively recent time frame evolutionarily, as well as, this was an invention. This was something that came to people as a light bulb above their head, or maybe they got hit in the head with an apple. But this was something that we did intentionally, and it was maybe in response to something, but still, this is what we were doing. So what I wanted to do instead was present a sort of alternative perspective on this, and how maybe there was a fair bit of luck and accident rather than design that was in all of this, and show how we often tell ourselves the story that we want to believe because we believe ourselves to be superior to every other creature on Earth. So this is the story of domestication. And so what better way to start than with these are rabbits. This is clearly how humans have manipulated animals. This rabbit is maybe slightly smaller than the perspective, because when you push it toward an image that's or a camera that's got a fisheye lens on it, and you put a little lens flare, it makes it very large. But all said and done, this is a very large rabbit. And these rabbits do not appear without our intention and our deliberate intention to make them much bigger. And I was at a talk about a decade ago at an animal conference in China, and I heard this amazing story about the origins of rabbits. And it went a little bit like this. This is Pope Pius, also known as Pope Gregory I. This is the best image that I could find of him online. If there are historians in the room, I'm sure you've got better ones. And this is the story. And this is from a direct quote from a paper that came out a few years ago. And they said that there is abundant historical information indicating that the true domestication process, including taming, selective breeding, occurred in French monasteries within the last 1,500 years. Presumably, this was inadvertently triggered by Pope Gregory I when, in 600 AD, he declared that lorises, a delicacy consisting of unborn or newly born rabbits, were not considered meat and thus suitable for eating during Lent. Great, fabulous story. And I sat in the audience rapt. I heard this and I was like, wow, that sounds phenomenal. It's almost like a Freakonomics kind of story, where there's this unintended side effect of the loris being consumed, and then Pope Gregory saying, well, it doesn't count to eat during Lent, so then French monks dashed out into the countryside, grabbed rabbits, threw them into hutches, and voila, we've got rabbits overnight. That's all you have to do to create them. And I was so sold on this. I bought this hook, line, and sinker that I had a master's student at the time. This is Evan, Irving Pease. He's looking pretty badass here. He just won a whole bunch of money, so that's why. And he's doing amazing things. And I said to Evan, we wanted to do a project where we're going to try and date the timing of domestication by looking at the genomics of it. Now that we knew that it was 600 AD, on like a Tuesday in March, presumably, if we used the genetics to try and we could recapitulate that same date, then we would be demonstrating that, we can actually use a genetic mechanism to come up with what the historians know to be true. So I sent Evan away, and I was like, and just off the side, make sure you get that papal decree, because it would be just nice to reference that. And that citation that I showed you just there, they didn't reference anything. And I just said, well, make sure you get that. Evan comes back to me 3 weeks later, and he says, Gregor, we got a problem. And I'm like, what's the problem? He says, the papal decree does not exist. I'm like, you mean it doesn't exist in our library? It means we have to go to Rome? We have to go somewhere to get one? And he says, no, it just simply doesn't exist. Even more, what he was able to do was piece together how that story was constructed. So it starts in AD 594. There is a Gregory who is a bishop of Tours, and he mentions in his writings the existence of lorises. There are people who at the time had a fetal rabbit and ate it and thought of it as a delicacy. That took place. That's all he says about it. Then in 600 AD, a completely different Gregory, not me, by the way, totally different Gregory, becomes pope in 600 AD. In 1936, we flash all the way forward, Nachstim, writing about rabbits, misrepresents Gregory of Tours as especially popular. Tours did not mention anything about the popularity, but Machstein then kind of mildly embellishes the story and calls them especially popular. In 1963, Zeuner, big domestication guy, writes that lorises were not considered meat. Again, invents this element of the story after recapitulating it from the get-go. Then Juliet Klettenbrock, another big name in domestication research, reifies the entire narrative and doesn't put any citations, which is great, because you don't have to then worry about where that information came from. You can just cite her at the introduction for your paper about any animal and just say, this is what happened. Arnold in 1994 introduces the aquatic notion as the reason for it not being meat, and then the American Livestock Breeds Conservancy in 2006 does the big switch. They swap St. Gregory of Tours with Pope Gregory, who had nothing whatsoever to do with each other, and then also said that there was a papal decree, which Evan demonstrated there absolutely was not. This gets cited by Wikipedia in 2006. In 2010, Sykes and Curl mentioned the aquatic story mentioned to the amniotic fluid of the rabbits, thereby justifying the watery environment so that they're fish so you can eat them during Lent. And then Carneiro in 2011 first tells the entire Pope story in a science paper. Recapitulated, so now it's in the scientific literature. So, okay, let's go back to this. This is the phrase, this is the story of how rabbits became domesticated that we all believe. Abundant historical information. What I love about that phrase, abundant historical information, is that if you say that and not cite anything, then people just believe you. There's a lot of it, I can't be bothered to possibly cite any of it. The true domestication process, so there's a false one out there, whatever, including taming, selective breeding, So let's now remove every element of this that is not just not fact, but completely invented through multiple iterations and embellishments upon a story that starts all the way back at 600 AD. And what are we left with? Yeah. So what do we know about rabbits? For rabbits, we know that alternatively, there is presumably this was. That's it. We got nothing more on rabbits. Fine. What's curious about this is that far from inventing agriculture, we are very good at inventing stories about how agriculture starts. And this is absolutely true of rabbits. Well then, how about, I don't know, let's pick another taxa. How about chickens? What do we know about chickens? This is a chicken-ish. We have clearly deliberately manipulated the chickens to demonstrate this particular thing, and we also eat a whole lot of them. There are how many million chickens in this image? And many, many more in warehouses all over the place. This is what we do with chickens. So clearly, if we're eating them now, we've always eaten them, and we were doing so from the very beginnings of agriculture, right? Absolutely. So, always presented with chickens. When? Neolithic. Why? Food. Maybe. If you believe the scientific literature, then this gets reified through all the stories. So this is a press release from a paper that came out about a decade ago. Prehistoric people in Bulgaria had domesticated chickens, ate Europe's first omelet, so we have the food element to it. 8,000 years ago, Neolithic-ish, especially for Eastern Europe, sure. So we have early Neolithic and definitely food. The Chinese, not to be outdone, they had their own PNAS paper. Early Holocene chicken domestication in northern China, they got 4 sites, they've got some bones. They look at the bones, they determine they're chickens. Never mind that image in B, there's a couple of dog bones in there. They clearly didn't have a zooarch on the paper. So this is what's happening in the literature. Not only that, you go to the popular literature, and what you have here, this is from a Canadian website. If you look at number 1 in the bottom right-hand side there, it says southern China, 6,000 BC, 8,000 years ago, evidence of chicken domestication. What is that evidence? Yeah, it doesn't exist. But it's okay, because if you put the word evidence, people believe you. It's fine. Then, there's a TED Talk that my mom just sent me this 2 days ago. She's like, oh, Gregor, you work on chickens. Did you see this TED Talk? And now, it is from 2018. It's had 5 million views. God, I wish I could get 5 million views for anything. Everything in this is 100% wrong, but that doesn't matter because it's on TED and therefore it's smart, and we tell each other these stories. So, what is the time frame of actual chickens? We did a paper a couple of years ago where these were claims from very early chickens that nobody had directly radiocarbon dated. And we thought, well, if we're going to reify this early Neolithic narrative, we need to at least get decent radiocarbon dates, because chicken bones have this nasty habit of kind of moving up and down archaeological stratigraphies and getting listed as something that's much older than they actually were. So these are all bones, these are the dates that they're supposed to be. We've got some 7,000, some 8,000. We direct radiocarbon date. What proportion of these came out with a completely different date when we directly dated them versus what the archaeological stratigraphy said? Yeah, that many. All wrong, all wrong. In fact, when we start looking at it, the earliest chickens that we possibly get, thanks to this guy, This is Joris Peters, looking pretty badass. He doesn't usually wear suits. I don't know where he's wearing a suit in this particular photo, but an archaeologist. He spent the better part of a decade traveling the world, going to every museum, every archaeological site, looking over every bone, taking every measurement, looking at every context, and was able to say, okay, this is now the definitive picture of when chickens actually emerge and how they then get distributed across the world, and it looks like this. We false color map, interpolate a map based upon the date, and what you can see is that the very earliest chickens we have here in peninsular Southeast Asia are 3,200 years ago. That's it. This is not 8,000, this is not 9,000, this is not early Neolithic. 3,200 years ago is the earliest that we have anything that might conceivably be a chicken. They move very quickly west and east across about the same latitudes. And then they have a little bit trouble going further north as it gets a bit colder, which we'll hear about later from Laurent's talk. But this is a relatively recent phenomenon and certainly has no truth in the idea that chickens are anything close to Neolithic. So, well, then clearly we were eating them for food. And this, a lot of times you'll see people saying, well, we eat them now. So people went up trees and grabbed red jungle fowl and pulled them down because we eat them now so much, we must have eaten them then. Except maybe not. This is Naomi Sykes looking pretty badass because she did a whole zooarchaeological interpretation of this. When she looks at the earliest chickens that we have in Europe, what you find is that the very first ones, about 2,500, 2,600 years ago, they are firstly, they're old and they're complete individuals. They are buried as individuals, as adults, in their own graves. You don't do that if you're eating it. So what's happening? Then what's happening is we see people being buried with chickens. Often in graves when you have full human burials, lots of other grave goods, but very often complete adult chickens. And what's amazing about this is that there's a site not that far from here, a few hundred kilometers east, near Vienna, and there are, at 650 AD, you will see that there's people being buried completely out there, and if you look at the bottom right, there's an entire chicken there. Now, what's curious about this is that these are actually older chickens, and when we look at the actual site, and we look at the delta N15, which is a dietary protein or a dietary isotope where you can measure how much protein the people are getting. Generally speaking, within the archaeological record, the more protein you're consuming, the kind of more elite you are. And everybody in this cemetery has a chicken. And the idea is, from our perspective, chickens are fungible. We don't care about them. They're all exactly the same. Why should anybody have any different chicken? Except for that when we match the delta N15 values from the people and the chickens, it turns out that the middle ones are there, the higher ones are a little bit higher, and we go all the way to the top, and the person at the very top has their very own chicken. So what this suggests is that they're not being buried with a chicken, they're being buried with their own chickens. They're being fed by themselves with people in those same contexts, and so everybody's got their own personal chicken, which means that these are being revered as animals and not thought of today as a sort of fungible units which we eat and throw away. And then what happens is we move forward a couple hundred years, we end up seeing a whole bunch of bones that do have cut marks on them, so people do start to eat them. The Romans are starting to eat them a little bit, and then we move to a very present context where now if you see a chicken bone on the street in any European city at night, it's just kind of tossed away as completely meaningless. So what happens, what's really interesting is that yes, people eat chickens now, and then they started really to eat chickens kind of around the Roman era, but what it also looks like, this is a relatively recent phenomenon. We have, both in England and in Germany, a whole series of archaeological sites where the proportion of chicken bones basically doubles at about 1000 AD. So chickens have been in Europe by that point about 1500 years or so, but it's 1000 AD when people really start going, oh, this is interesting, let's start eating more of these. And why are they doing that? We also have a gene called TSHR, where that starts to, the thyroid-stimulating hormone receptor starts to kick off and get really heavily selected toward its modern fixation, also about 1000 AD, which, curiously, is at the same time when there were these things called the Benedictine reforms, also about 1000 AD. It was a return to monastic living, religious dietary restrictions, and very, very importantly, four-legged meat was bad. You couldn't eat it for about a third of the year, but chickens and eggs were okay. Fasting was both a religious and legal requirement across Europe when there was a lot more state control of what people could eat. And all of this then started pushing people more toward eating chicken than eating what they were primarily used to as a protein source. And so we have three different lines of evidence, historically, zooarchaeologically, and genetically, suggesting that the big fad for eating chickens, which had been around for a good 1,000 years or so, but really only kicks off toward its kind of modern fast food element of it about 1,000 years ago. And purely as an accident of the cultural and religious doctrines that were around at the time. So, When chickens first get to Europe, they are revered. They are thought of as gods at the time. There's nothing, no other bird that has that kind of color, no other bird that squawks or has that kind of sound with it. They're associated with rising suns. They're the national bird of France. They're on coins. They are just absolutely adored. But familiarity breeds contempt. And after, I don't know, about 500 years, that contempt breeds indifference, and that indifference begins consumption. So when chickens first arrive, far from being eaten, they are thought of as absolutely the most important thing around, but then people kind of get bored and then it starts to happen over a period of time. So it's almost as though if something first shows up, imagine an alien lands right now. We're not eating it, but because it's so different. And there's a very big correlation between the actual geographic distance from where something comes from and the amount of kind of supernatural importance that it has as well. But after time, you start to become a bit more accustomed to it, becomes less important, it's less of a big deal. At first, you're revering the chickens. You set your iPhone for 500 years. 500 years, the alarm goes off, and you start eating it for dinner. So, far from the rationale of why chickens became domesticated, as it were, was not because somebody grabbed a chicken that was frankly quite scrawny, and we'll see images of that later too. It is a much longer protracted thing, which now ends up as the single most consumed meat on Earth, but the story of it is much more nuanced and much more curious and different than simply we grab some out of a tree. So if not food, what's actually happening with chickens? And that's kind of an interesting thing. How are they becoming associated with people to be moved across Eurasia relatively rapidly at about 3,500 years ago? So what we found, and this is a little bit of speculation, but predicated upon some really neat empirical fact, was that in peninsular Southeast Asia, where we are first finding the zooarchaeological remains of chickens, it's happening at sites where it's the first time that you start to see dry rice agriculture coming in. There had been wet rice agriculture in this region, but dry rice agriculture, which also appears in this region at 3,500 years ago, has a completely different ecological footprint. And the rice kind of mimics the bamboo blooms, which the red jungle fowl eat all the time, which they then recognize as a food source for them. So the dry rice agricultural footprint actually then acts as a magnet, pulling chickens toward people rather than us going back out after them. They get associated with people, and then they start moving with people where you can change out the rice from, change out the grain from rice to millet, then even to wheat when it starts to get toward the Near East. So rather than this being a deliberate action where people are going out and grabbing these things because they know in a few thousand years we're going to be eating them on the scale that we are currently, it's more that there was this unique relationship that got formed simply by a consequence of the kind of evolutionary and ecological impact that dry rice agriculture had on coming into a region where you find the red jungle fowl that then became chickens from there. How about another taxa? So if not chickens, let's go, how about cats? Now, we don't eat cats, but they're certainly domesticated, or at least partly so. This is Sean Doherty looking like a bit of a badass because this paper is about to come out, although we've had a little bit of a hiccup recently. So when? Neolithic, clearly, right? And I put food here in parentheses because it's not that we're eating cats. The narrative is instead, of course, that the cats eat the mice, which eat the grain, which were in the stores that people first develop when they start doing large-scale food agriculture and settled agricultural systems in the Neolithic, in the Levant. Great story, and it's repeated ad nauseum in the scientific literature. And there's some mild evidence for it, which is on this particular site in Cyprus called Chilocambos, which Jean Denis excavated, where there is a human burial next to a cat burial on the island of Cyprus, where cats cannot get by swimming. So this suggests that people are bringing the cats with them, and that they're being buried with them, and therefore it's domestic. And that's all you need is the nice narrative, then how it goes with the mice and goes with the rice. The existence of a buried animal alone, though, does not necessarily mean domestication. This is Ali Siegenthaler looking like a bit of a badass because this paper is just about to come out, where she did a whole record of full animal skeletons buried across the entire planet at various times. And what you find is that if it's a canid that's buried and you look in the literature, people go, oh, evidence of a close relationship must be a dog. If it's a felid, close relationship must be a cat. But nobody says that about the site in Peru that's 500 AD, where you get this. An entire skeleton of a full animal. In fact, there's like 3 or 4 of these. These are pelagic sharks. I put to you that these are not domesticated pelagic sharks. But they are buried as complete individuals, and they are on the same plateau in the same region where you get humans buried in exactly the same way. So people bury whole animals for a whole variety of different reasons. It has nothing to do with the domestic status. And that cat, we suspect, is probably very similar. So if you look at the humerus of this particular cat that's buried, what you get is a whole bunch of Felis sylvestris, which is the European cat, not the cat from which the domestic cats are derived, which is the Felis libica. And the humerus of this particular animal is nowhere near that, it's up there, looking much more like a sylvestris, looking much more like it was buried as a complete individual from a population that itself was never gone through that domestication process. So this is Claudio Toni, looking like a badass because his paper is about to come out too. And what he's got is ancient genomes from buried felids, or at least recovered felids from zooarchaeological assemblages all over Europe, a handful in the Levant and a few other places. And he's got a time frame for all of this. So in yellow, you have the Felis libica. In green, you've got the Felis sylvestris. And what he's got is just libica, or sylvestris, 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 and far from being Neolithic, the very first time we see anything 2,000 years ago. Cats, like chickens, are a very recent addition to the whole of the human kind of adventure, and it's only we're really starting to see the spread of them with the Romans. We thought there was a few before that, turns out that's probably not correct, and that humans are not just spreading libica as domestic, they're also spreading a population of libica as wild to the island of Sardinia, also about the same time. So, when? Probably about 4,000. Where? Well, we're back to Egypt, which is what people have been saying the entire time before the mice and grain narrative started to take over. And what's interesting, that if it's not grain and mice, then what's the rationale then for cats? What's happening here? Is, again, people going out and grabbing them? Well, in this case, kind of interesting. So we first start to see imagery of cats within Egyptian settings. There's one under the chair there, there's another one under a table, curiously kind of eating some fish, and we start to see them happening there. But what's really kind of curious is that there is this goddess, which is she's a very big deal. Her name is Bast or Bastet, and from 2700 BC to 900 BC, always portrayed as a human body with a lion head. And there's Bubastis there, where there is a huge place where people make pilgrimages, kind of like modern pilgrimages like the Hajj. And when you go to make pilgrimages, you don't take anything with you, but when you arrive, you have to give a cat. And what's interesting is from 900 BC onwards, she stops being presented as a lion head and more of a head of something that looks much more like a Felis libica. Whether domestic or wild status is kind of irrelevant at this point. It's a different species. And in this particular case, what people are doing is they're showing up with cat mummies. Now, you don't bring in your own cat mummy. You get one when you're there. It's like if you go into any church now, if you want to put a candle up front, you're not bringing your own candle from home. You buy one for £1 or €1, and then you put one up at the front of the church. In exactly the same way, people are acquiring their cat mummies in order to give them to Best as an homage after their long pilgrimage to get to Babalis. And when they do so, they just probably recently acquired it. Now, one little side tangent story, which is a lot of fun. There is a non-0% of these mummies that are not cats inside. So there are people who are hanging out near the front going, hey, you need a cat, right? Yeah, I need a cat. You want, I got cheap ones. I got 20% off. Are you sure that's a cat? Oh, it's definitely a cat. It's not a cat. They used all kinds of other taxa, mummified them, put the cat heads on them to make them look like cats, and then sold them for cheaply. And there are so many of these that they then were used as fertilizer in the 1920s in the UK because they were bringing them all back and then spreading them all over the fields because there's hundreds of millions of these things, or at least tens of millions. So this is an image from... So what happens in order to get that many cats to drive that demand, there's an island nearby where all of the libica are there, and it's just a factory of murder. They're just bringing all the cats in. At 6 months old, they're knocking them all on the head. They wrap them up as money, give them to mummies, give them to people so they can put them at the front, and then they get taken off and putting them into the sarcophagus. So this is a cat that I started with. It's actually from a headline from The Onion, the ironic newspaper in the US, and it's the whole image is kitten things but nothing but murder all day, which is pretty funny. But if you are a cat and it's 4,000 years ago in Egypt, I needed to change this and put kitten things of nothing but getting murdered all day, just because that's probably what's happening here. And it's that kind of close association with people and murdering the cats that forces them into a small space, forces them to reproduce in close proximity to each other, which wild libica will not do, and that then starts this relationship that brings them closer into people, and that's really what kicks off the entire thing. So, I wanted to mention two very quick things just before concluding. One is that this is an animal that maybe very few of us in the audience have ever even considered eating. These are Japanese wasps, and there's a whole cultural industry around you go into the forest, you find where these nests are, and then you bring them back, and then you put the wasps in nests that you find into wooden boxes. You allow them to lay the eggs and to get the larvae, and then the larvae look like this, delicious, and you then eat the larvae. You can dip them, you can either cook them or eat them raw, and it becomes a thing. And it's almost less about the consumption of the larva as it is just about the method where you get your friends together and you go out and you spend hours trying to find them. And so there's a whole interesting kind of way in which humans and these wasps has formed this relationship whereby we are clearly manipulating them in order to have more of them to get them into a stage where we can then eat them. But the real driver over the last 30 years have been contests, which is kind of curious because if we think about like farm contests, where who can produce like the biggest watermelon or the biggest pumpkin, it's similarly in Japan, it's who can get the biggest larvae or the biggest wasps and the biggest and the tastiest larvae. So you have all these contests around us driving this, where people are making more of a demand for it, and then altering their life systems by producing the wooden boxes where you can keep them a little bit more. So there were, in this paper, in this ethnography, they did a big interview with them. And the really curious thing about this was, when you look at it, it kind of looks like domestication. It's what we would say, you're controlling the life cycle of a particular organism for your own benefit, especially even for consumption. But when they talked to everybody who was involved in this, they said that an intention to domesticate does not seem to be part of these wasp-human relations. None of the carers expressed that the goal of their deliberate action was hereditary reorganization. Not a single person used that word and said, we are trying to domesticate these wasps. Instead, their interest was to help ensure that there would simply be more wasp nests to be found the following season. That was it. They were just trying to, if it was a particularly cold winter, then sometimes the wasp nests fail, so you give them a little bit of protection because there's more of them. So it sounds like domestication on the back end, but that's not what anybody was actually trying to do. And lastly, the practices of care are having impacts on the selection and adaptation within the populations, but it was never the carer's expressed intention. And that's kind of where I want to go with this, is that we can see it retrospectively as a good idea or a bad idea, but it was an idea. And it was something that we did, but I'm suggesting no, it wasn't. It was just that there was a short-term problem or a short-term opportunity that we were going out to try and solve, so that part is deliberate. But the long-term, multi-generational, multi-decadal, multi-millennial impacts of this from now look like domestication, look like it was intentional, look like we climbed the tree to grab the red jungle fowl, but that's not what it was. It's short-term, you solve it, and then you only look back and go, oh yeah, that was a really smart idea, that's what we tried to do. In fact, there was this really great paper that I'm so jealous of. I wish I would have written it, or at least been involved in the production of it. These are some good friends on this paper. And what they said was that plant domestication itself likely proceeded as a process of what they refer to as unintended entanglements, as people became more reliant on specific methods of food production involving irreversible labor traps. Now, there's some really interesting ideas here, one of which is everybody in this room has a phone. Everybody in this room does two-figure authentication or whatever, but that's not what phones were designed for. And now we're all so heavily reliant on our phones that I doubt that any of us would ever go, ooh, you know what? We domesticated our phones because we think it was a really good idea. Most of what we do with our phones now was never the whole plan from the beginning, no matter how much we want to try and tell ourselves this very positivist, very high-intention, highly intelligent human story behind the whole thing. And lastly, this is Jack Harlan. I'm certainly not the first person to say any of these ideas. I'm just riffing off of what a whole bunch of other people have done for a very long period of time. But what I'm curious about is the degree to which the other side, the positive idea, just seems to be the thing that we always do. It's the story that we always tell ourselves. So much so that we invent narratives around the production of, say, the rabbits in the first place, of which this story is not true at all. Not a single snippet of it has even any bearing in empirical fact. And what he said was that, first, we will not and cannot find a time or place of agriculture originated because it did not happen that way. Agriculture is not the result of a happening, an idea, an invention, or discovery. And that part I tend to agree with. I think for me, he goes a little bit further with the pendulum than I would like on this last portion, where he says it emerged as a result of long periods of intimate coevolution between plants and humans over millennia, over vast regions. I like the intimacy, it sounds great, but whether or not it was, I think there were other elements to this where we involve cultural elements and tools and technology and things where we can kind of play to, there's this tension between how intentional and how accidental, how opportunistic and how deliberate. All these words get kind of pushed together in really interesting ways, and I think one image kind of summarizes that, which is these guys, right? No one is going to deny that there is a significant degree of intentionality here. Bees were deliberately selected for their feather color, for their placement of the feathers, and for everything else. But at the same time, nobody 3,500 years ago was ever planning for this to happen. And I just would like to end that at least we can all agree, regardless of where that tension is between deliberate and an accident and everything else, that there's something deeply, deeply funny about these, and thank God for that. Thank you very much.
Thank you, Professor Larson, for this very good presentation. For you as well, we have no time yet for a question, but we will have the podium discussion. Just few technical information before letting you go to grab the coffee and something sweet. We will restart at 11:10, so I give you 10 more minutes for the coffee break. We will recover this time later. But at 11, in this room, we will show a teaser of a movie called Word Without Cow, produced by Alltech. It's very interesting. It's a teaser for a much larger movie. So grab your coffee and come back here at 11 for the start of this teaser. We will start the plenary session at 11:10. Thank you very much.
that we would be the ones to tell this story.
Right, but the more we learned, it was like we didn't have a choice. We had a responsibility. We had to tell this story.
The challenge is every day between now and 2050, it gets harder to feed the world.
Get going, farmer. It's up to you.
Farmer, save democracy.
More beans.
Farmer, save the world.
More milk.
More.
For 10,000 years, farmers and ranchers have been asked to do one thing.
More grain.
More grain for bread. Grain for life.
And that's produce more food.
What happens if we keep eating animal products on this scale is climate change continues to be exacerbated, which is tantamount to slow suicide.
Everything on the news, everything online, everything told us cows are negatively impacting our lives.
For decades, agriculture's done a pretty terrible job of telling its own story. And the problem there is when you don't tell your own story, you allow someone else to tell your story. And when they start telling your story, they have their own biases, their perceptions, their own agendas.
They fill in the blanks wherever they want to, and then their perception basically becomes reality to them.
We're filmmakers, and we work in agriculture for an animal health and nutrition company.
We travel the globe telling stories about sustainable farming. Together, we've been to 22 countries on 5 different continents. Literally around the world, farmers just open their doors to us.
And what we've experienced on these farms is completely different than what we're hearing.
We really started to question ourselves. What are we missing?
Maybe we're wrong. We wanted to put the pieces together to try to make sense of it.
We set out to explore one question. Are we better off in a world without cows?
In the beginning of all this, all we had was the basic idea of what does the world look like without cows? So that set us off on this journey of we talked to literally dozens and dozens of people around the world, various experts in a number of different fields. And we posed that question, what does a world without cows look like to you? And that kind of brought 3 main things into focus.
Yeah, we had basically 3 big ideas come out of those conversations. What is a cow's impact on culture and economy? What is a cow's role in feeding the world? And what's a cow's impact on our climate?
What's interesting about that is it didn't matter what country we were in, what region of the world, it always came back to those 3 things. It's never, this conversation is not just about one of those items. It's always this encompassing idea that cattle make a huge impact in all these areas, in all of our lives, in ways we don't even know about.
For the Maasai, cattle represent more than food and wealth. They're a symbol of heritage, a connection to the land.
Cattle are very, very important in Maasai culture. It supports our livelihood.
The tribe's about 2 million strong. They coexist with their cows. Here there's no money, only cattle.
You go to my bank, it doesn't have money.
When we think about upcycling, it's taking something of lower value and making a higher value product. These animals take feedstuffs that are low quality protein and lower percent protein, and they make a high quality protein product for people, whether that's meat or milk.
They produce more edible food than what you feed them. That's obviously really, really important when we talk about being able to feed the world, and our ability to do that is making more from less.
Cows and agriculture and livestock, they do contribute to climate change. We've got to be realistic about this.
I'm not a person telling you livestock has no impact or it's a tiny impact and so on. Every time a cow belches, she puts out methane. Methane is CH4. And the C in the CH4 is the carbon. We are concerned today about not adding additional carbon to our atmosphere to keep our planet from additional warming. Are ruminants in particular really that big of a climate threat?
So the narrative that's out there right now, to be honest, it's pretty negative. And it's kind of striking to us because as we started on this journey, the number of farms we've been to, we didn't feel or see that negativity. It was quite the opposite, in fact.
And so when we started this project, I'll be honest, I was a little nervous about what we would find because our backgrounds are in journalism. And I truly do still feel kind of that moral obligation to tell the truth. And so I was nervous with all of the content that's out there. Maybe some of it's true, maybe some of it's half truth. And so at the end of the day, for us, for me especially, it was like, I want to talk to the people that have the expertise, the experience on both sides. And what that truth is, that's the story I want to tell.
It became really obvious throughout this production process as we went around the world. We really saw an increased interest in people wanting to know where their food comes from. So you're seeing a lot more documentaries out there right now about food and the environment because people have this interest now in sustainability and the environment and also what we do as humans and our role on planet Earth.
It was really important of who has the expertise and the ownership to talk about those areas. So this isn't just an opinion-based conversation where people are yelling their own thoughts and opinions at you. These are doctors, PhDs, farmers, ranchers, people that have firsthand experience and education in all these areas to give the authority behind what they're talking about. It's facts, it's science. It's based in science, it's based on experience. This isn't just opinions being yelled at you by talking heads.
It used to be where if you were a farmer or a rancher, you were held in high esteem. It was a noble career. Now, farmers and ranchers are often vilified. It doesn't have to be like that.
I think one of the things that surprised me the most is not a single farmer or rancher that we asked to be a part of this film said no. They were all very welcoming, and in fact, every time we went on a farm, what they told us was, we wish more people would come onto our farm so they could see how we do things, what we do, because they feel that the public in a lot of cases doesn't trust them, perhaps vilifies them.
No, I just want to reiterate that. Literally every single person we talked to in ag about this project was jumping at the chance. They said, how do I become a part of that? What part of my story can I tell you? Where do you want to visit? I got multiple farms, come see it all. Because the reality is they're eager to share their story. They just didn't have the medium to share. They didn't have the mechanism. They didn't have the know-how. So hopefully this helps share part of that really important story, getting people behind the scenes, having these important conversations.
By the time we were finished with all the conversations, when it came down to it, it didn't matter what side you were on, you were actually a lot closer than you thought you were.
Right.
The two sides are have a lot more in common than they do different.
Right. I think it's just realizing those moments, finding that common ground. And that's really the ultimate goal of this production, of this movie, is to start those conversations, because that's ultimately how we make a difference. I think people are sick and tired of people screaming at each other from opposite sides of the aisle. How do we bring people together? How do we have these meaningful conversations that ultimately create the change that's needed?
As scientists, we can give you the first half of the information, but the next is a social and political discussion, and that's where the conversation hasn't really started yet.
Part of the reason why the world without cows is interesting is because it forces people to have a different conversation.
We're really excited to be at this point, to share this story with you and to start all these very important conversations. You can find a lot more information on our website. That's worldwithoutcows.com.
There you can sign up for more information to learn about the latest updates about the film, see available screenings, and also discover more about cattle's role and their impact on our world. Thank you.
I hope that you can hear me also from outside, and you are now taking place again. I would like to introduce our third speaker of the plenary session. That is Professor Haskel Greenfield. He is Professor of Anthropology, co-director of the Near Eastern Biblical Archaeology Lab, and coordinator of the Judaic Studies Program, University of Manitoba in Canada. He is an anthropological archaeologist whose research focuses on early agriculture and complex studies in the whole world from the Neolithic to Iron Age. He has conducted research on butchering technology, spread of metallurgy, regional substances, and land use. Professor Greenfield, the stage is yours. Thank you very much, and I also ask him to switch off the light here on the podium if it's possible. There's, I think, decreasing a bit intensity.
Okay.
Please, Professor Greenfield, the stage is yours.
Thank you very much. Hopefully everyone can hear me when I speak. If I lose the microphone, just yell at me. I have 4 children, no problem being yelled at. It's just a normal part of my life. Okay. Now, I'm going to start today telling a story. The story is always about myself, because I've learned through the years I can poke fun at myself. I don't poke fun at other people because it gets me in trouble. And today I'm going to take the tone of the 2 earlier talks today and shift it into the issue of primary and secondary animal products, when they first appeared, and what can we tell them. And of course, I'm going to have to update some of it because I've learned today some of it is out of date, and you know, that's always the beauty of science, is knowing when you're wrong. But being able to admit it, that comes with, never mind. Okay, primary and secondary products revolutions in the old world, a zooarchaeological perspective. I'm a zoo archaeologist. I'm an anthropological trained archaeologist with a specialty in zoology. I'm not a zoologist, I'm a pseudo-zoologist because I'm really an archaeologist. So I acknowledge my limitations. So, prologue. Long time ago, there was a little boy who fell in love with archaeology, and as he was growing up, he dreamed of finding dinosaurs, mummies, and ancient gold. That's, by the way, me. You know, unfortunately, he was born with the inability to digest cow's milk, lactose intolerant. If you're coming from, you know, Mediterranean background of some type, you're going to have lactose intolerance. And you can see me and my mother there. So instead of raising him on mommy's milk, because this was the era of the 1950s where Dr. Spock said that women should not nurse their children, my mother refused to breastfeed, and they had to find something for me to drink, and so I was raised on goat's milk until I was old enough to get over the clear allergies. These are just some of my children playing with goats. So herein lies my long interest in the origins of milking and, of course, secondary animal products. But then, as I grew a little bit older, I discovered meat, and meat is the primary product. And so I began, as part of my research, to deal with the origins of primary and secondary products. And when does it first appear? We all assume that animals were domesticated for certain reasons. In fact, it's not true. So animal primary and secondary products, these all come from domesticated animals. You can get both from many, many of these species that we've domesticated over time. And so I'm going to look at when these things appeared, how they affected our lifestyle. In other words, how did we get into the mess that we're in today? So an earlier speaker talked about the evolution of domestication. Yes, when did domestication take place? Maximum, in terms of sheep, goat, cattle, and the like, maximum 12,000 years ago, and probably even less, probably closer to 10,000 for the oldest now. That represents less than 1% of our time as our own genus of Homo. So, but what domestication did lead to is all kinds of changes in our biology. It led to poorer health. We can see this with backaches. We can see this with all kinds of pathological problems that show up in the spines. It shows up in diseases. For example, smallpox, chickenpox, all these things is because of proximity of humans that never existed when we were mobile foragers or hunters and gatherers, because if someone got sick and you're a forager, you just picked up and left them. And, the tribe continued. It led to population growth, because as soon as people start settling down and start domesticating animals, they started popping out more babies instead of having to space babies every 4 to 5 years, as we see with modern hunters and gatherers, because someone has to carry the child who's not yet walking, and someone has to carry the gear. They could pop out babies every year. And we see dramatic population growth as a result. And diets become poorer, they're less diverse, and the status, in particular of women, declines with the advent of domestication. Now, food production is really a recent aberration for humans, because effectively we evolved as foragers, hunters and gatherers. And you can sort of see this with Canadian First Nations. Here's some data from several years ago. It's actually gotten worse, where the prevalence of diabetes type 2 just has skyrocketed as these people were forcibly settled down into reservations, and then they were basically force-fed. The only food that was made available were European-style diets, of which their bodies were not biologically adapted to. And they've gone into, there's been huge increase in the numbers of people with diabetes type 2 as a result, which is not normal in their pre-modern population. So, food production is the basis of all modern lifestyles. Very few people around the world today live by hunting and gathering, except one of my daughters and her son, who are avid hunters and fishers. But basically, complex societies of tribal societies, chiefdom societies, early state societies, empires, all these are based upon the excess production that comes out of domesticating plants and animals. We couldn't have these kind of complex societies that we have today unless we had an assured, an assured food supply that's actually done by a few people who free up the rest of us in order for us to do other kinds of things. So let's step back for a second and look at what is food production. Food production, rather than talking about domestication of plants and animals, this is all about food production, is being able to grow or raise, control the growth of animals and plants. And there's several different types of food production. We've heard a lot about them today as well as yesterday. There's agriculture, there's pastoralism, there's aquaculture. I actually don't like when people say farmers are keeping animals. Farmers are really people who deal with plants. Herders are the ones who deal with animals. And you can talk about mixed farming, herding kinds of economies, but you should never mix up the two. So, was it the greatest mistake that ever occurred to humanity Did we go down the wrong pathway in order to become food producers? Is our life better? Well, anthropologists have done time studies on modern hunters and gatherers, whether they're living in Africa or Australia or South America or the Arctic. And what they find on average when they measure time across a year, these guys are working about 2 hours a day in order to get to be able to meet their basic subsistence needs. 2 hours a day. Contrast that with a farmer. Why, and you have to think of why would you abandon a lifestyle where you're doing 2 hours a day and then become a farmer or a herder where you've got to work longer, harder hours. Anybody who spends time on farms knows that a typical farmer or a typical herder spends 12, 15 hours a day. And at harvest time, it could be a 24-hour-a-day thing when it comes in. I live in Winnipeg, Manitoba, in the center of Canada, and I'm surrounded by huge farms. And these guys are out there, even when it's dark, working their fields. And there's no vacations. You can't just leave the farm behind. They can't leave the animals. So why did we do this? Why did we do this to ourselves? Well, there's all kinds of reasons that have been proposed, but from my perspective, it's really to even out the availability of food. Food as a forager is not available throughout the year or from year to year even in the same quantities or the same predictability. By controlling your food production, it means you at least know how much food is coming in, when it's going to come in, and how to manage it so you'll have enough food to last all year long. In the Canadian prairies, which used to be heavily buffalo, there was always a time from March until the end of May that was called the starvation season. This is when the traditional hunters and gatherers living out there had no food. Nothing was growing. The animals were all too lean to eat, and there was very few animals at that point. They were mostly had migrated to the south. So the development of refrigeration changed, because before that, if you wanted to be a herder, you could store your excess food by feeding animals your grain to basically use a term coined by Clayton Brock, which was refrigerator on the hoof. This is if you have extra food, you give it to the animal's alive, you can slaughter it later on, and the food doesn't go rotten. Refrigeration in my province, in the city, only appeared in the 1930s. It didn't get into the farming communities until the 1980s. So people were still using ice boxes until recently where we live. So when did food production start? Well, the earliest really is about 10,000 years ago. It's associated with what we call the pre-pottery Neolithic. It's not associated with what we call the Mesolithic or the Natufian culture. Those are still hunters and gatherers who happen to settle down. It leads to domestication, but it's not when domestication happens. So the pre-pottery Neolithic of the Near East is when all this happened. This is happening before it happens in India or Europe or China or Egypt and so on and so forth. And it's happening in a few places in the Near East. It's mostly happening in the mountain zones that surround what we consider Mesopotamia. You can sort of see that here. It's going up and around. Not in the lowlands of Mesopotamia, not in the lowlands of Syria. It's happening up in the mountain zones where the wild progenitors of all these animals and plants exist. It can't happen where the wild forms don't exist. And what type of animal was domesticated? Gregarious animals, animals that live in herds. They're the most easily to domesticate. You can have a sheep. You have a sheep or a goat, and the rest of the herd will follow it. So you follow the dominant member, just like you see this here. Anybody know what species we're looking at? It's us. We are a herd animal. We're gregarious. Look at, everybody's here. So yes, in some ways we are already domesticated. Why were they domesticated? For their primary products. Now, primary products are products that you have to kill the animal for. You can't go back to it over and over again. You can go to the animal once in their lifetime. Here we are slaughtering a goat or a sheep in Bosnia. So you can get fat, gut, meat, hide, skin, bone, blood in large amounts. Yes, you can get blood in small amounts, as we see in some herding societies in sub-Saharan Africa, but you can't take too much or else you kill the animal. Secondary products are different. They're products that you can go back to the animal over and over and over again throughout its lifetime. So the animal continues to be productive. And so there's a long-term return on your energy investment if you're going after secondary products. Primary products is really a short-term strategy, because once you've killed the animal, you can't go back to it again and again. And so you can get milk, as you've just seen. You can get wool from sheep, for example. You can get hair from goats. You can use them for traction, in other words, to pull wagons and plows. And lots of animals have been used for secondary products in this way, like horses, cattle, donkeys. Actually, I prefer to call them asses. That's really the more appropriate name. So don't talk about donkeys. Donkeys actually is only about 200 or 300 years old, that word in the English language. So the real term has always been ass. And you can make all kinds of great jokes when you're talking about asses. So just something to think about. Now, other secondary products are, for example, hunting. Dogs were probably domesticated sometime between 25 and 30,000 years ago. For transport, you get cattle, donkeys, horses, camels, and they're all domesticated at very, very different times. For example, now we're pretty sure that the Arabian camel was only domesticated somewhere about 12 or 1300 BCE, versus the Bactrian camel seems to be domesticated much earlier, 1,000 or more years before that. Companionship, dogs and cats are being used. And dogs, for sure we can, people are burying themselves with their dogs. They're burying, as we saw earlier, they're burying with cats. It could be a wild cat still, but cats get tamed. And so it could still be your favorite pet. Or rodent infestation. They may not have been domesticated purposely. They probably were not domesticated purposely for cats. Cats for rodent infestation. But as soon as people settle down, mice and other rodents start appearing in the houses. And, it's just a nice commensal relationship if you have a cat around. It may not be domesticated, but, and of course, dung as fertilizer and fuel. So some of the earliest written records for the secondary products start appearing with the earliest written documents in Mesopotamia. Here's just an example of one from about 3500 BCE, where you can see where wagons and wool and plows are all mentioned, in these early tablets. In fact, the earliest written records are by accountants. It's, they're not making the great epics of Gilgamesh or any of the kind of thing. These are the guys who are counting how many sheep, how many goats, how many bales of wool are coming into the temples, and they're recording. So just think of be nice to your accountant, because your accountant is a descendant of the earliest people writing. You can sort of see a pictograph of a plow up here, and this becomes the cuneiform style after about 1,000 years for it. Could animals have been domesticated for their secondary products? Unlikely. Because, for example, we know from the wild ancestor of domestic cattle is the aurochs or Bos primigenius. There's none of them alive anymore. They were hunted into extinction in the last one in the forests of eastern Poland, somewhere in the early 17th century. If you go to Krakow, the castle, you'll actually see the horns of these cattle still on display. But primitive domestic cattle produce relatively little milk, and you have to keep the calf near the mother, in order for it to let down its milk. And if you kill the infant, often the mother's milk dries up. So you're always going to be competing with the baby for this. But we find actually in very early Sumerian times, from also about 3500 BC, here's a cylinder seal, for example. You can sort of see the cylinder seal here with a nice decoration on top. It's a fancy one. It's about the size of my finger. It's a very, very small thing. But when you roll it out, you can see here cattle, and then it looks probably sheep. People have interpreted maybe calves here, and jars of probably milk. So the milk is being stored in large jars while the animals are being tethered. But you have to ask, well, we've domesticated pigs. Why don't we milk pigs? Just like milk organs are being transplanted into humans because they're biologically much more similar to us than most other animals, pig's milk actually is very nutritious. Pigs produce lots of milk. They have litters of 8 or 10, and so they got to feed these. And in fact, those people who've studied pig milk, it's just something that goes nicely in our culture because people think of pigs as dirty. Pig milk is very nutritious. So why don't we milk them? Well, we can milk dogs, you can milk cows, you can milk all kinds of animals in the same way, because they don't stand up while lactating. We only milk animals that stand up while lactating. So you can make all kinds of comments which I prefer not to say now about that. Okay, and what are early iconographic records? You can really see here, for example, the baby over here, the calf over here, while milking. You have goats being milked here, and there's somewhere in here, I seem to remember there was a calf, a baby goat as well. Now, how old do we have for the earliest milks? Now, Richard Evershed from the University of Manchester, about 20 years ago, figured out a way to extract remnant milk lipids out of ancient ceramics. And he's done it going back now to the earliest ceramics in the Near East, going back to about 6,000 BCE, or about 8,000 years. But pottery actually appears 2,000 years after animals are being domesticated. So we don't really know what's in those earliest phases of domestication in terms of milk. But we do, and also we can't tell who's being milked. All he can tell us is that it's a ruminant, or he can tell it's an equid, or when he's worked in stuff from Kazakhstan. But he can't tell us, is it a sheep, is it a goat, is it a cow, or is it a pig? Someone decided to get down under a pig finally. And also the frequency of ceramics where he finds milk lipids, he's not finding them in every ceramic, and it really depends where he is. The farther north he goes in Europe, the higher percentage of milk that he finds in the ceramics, but in comparison to the Middle East. So I actually worked on a project for many years, and this is a ternary graph where you got 3 poles. Instead of having a histogram, you can do three different variables, and here's just, it's mapping out the distribution of sheep and goat at different ages, whether they're immature, less than a year, subadult, or adult, from archaeological sites in the Balkans. And the distribution of sheep and goats is remarkably different. And many archaeologists, in particular many zoo archaeologists, don't distinguish between sheep and goat. You have to be able to distinguish down to the species. And today, if you're really good, we can do at least 50% of the skeletal elements, unlike 50 years ago. But you can sort of see sheep are being killed young, Goats are being killed old in the earliest sites in the Balkans, which lends itself to the interpretation that goats are the earliest milking animals, not cattle, not sheep. Wool is another secondary product. Now, it's interesting, when we have cloth fragments preserving from the Neolithic and from the Chalcolithic with the Bronze Age and the Iron Age, and we don't see any wool until the Bronze Age, or the Chalcolithic, depends on where you are, because the Chalcolithic in Israel, for example, would be equivalent to the Neolithic in Europe, because things are happening earlier in the Middle East. But in a cave site in the Israeli Negev called Nachal Mishmar, or the Cave of Treasure, there's a huge copper hoard from about 4,500 or so BCE, and it's in a flax bag or linen bag. So we're not seeing wool. And we don't see wool showing up until much later. Now, why don't we see wool showing up much later? It has a lot to do with sheep and their sheep biology. The ancestors of wild sheep, or wild sheep, if you look at a wild sheep does not have wool as its exterior coat. It has hair, just like a goat does. And there's, you got long, coarse hairs over here versus fine wool kind of undercoat. And this change from an outer coat that is hair to an outer coat that is wool, in fact, took several thousand years to take place, and it probably wasn't for purposeful breeding. It's often you can have all kinds of random changes happening in small populations, and that's what herders want, to keep the populations isolated from other ones. So sometime after 5,000 BC or so, in other words, after almost 3,000 years after domestication, does woolly sheep start appearing. And we start seeing them in the form of figurines. First, here's a figurine from the mountains of Iran, a site called Tepe Zarab, and you can sort of see these hatches on it. These are diagrams showing what is probably was interpreted as an early wool individual. And then from later times, you can actually see more, clearly woolly sheep, but these are much, much later in time. Traction. Traction is pulling, and we often associate with pulling the wagon, the plow. These don't seem to develop until after 3,500 or so BCE again. And in fact, the early colonization of Europe by Near Eastern farmers that started about 7,000 or so BCE, there's no wagon out there. So they're either using sledges like this or carrying the gear across Europe all the way to the British Isles and all the way to Scandinavia. Some of the earliest evidence we have for wagons, for example, in Europe is from a site in Hungary. You can sort of see a clay model. These are big, probably clunky ox carts, solid wheels, slow moving. We don't see chariots, in other words, spokes, until the late Bronze Age. Sometime after, in Europe after 1200 BCE, in the Middle East after 1500 BCE. Early evidence for the plow in Mesopotamia, iconographically, you can see here's another cylinder seal that's rolled out, and you can see the plow being pulled by, looks like two oxen. Now, you have to remember, the plow creates a revolution in food production, because during the Neolithic, after they domesticated plants, everybody has to do hoe agriculture. So you need 100 people out there in the field in order to till it in time to get the food there. But when you get to the post-Neolithic, in other words, the Chalcolithic and the Bronze Age, where you start having a plow, a single person with a pair of oxen can plow that same field that was 100 people. So that releases 99 other people to do other things in society. And all of a sudden, you start seeing productive specialization taking place where people can be and a dramatic increase in trade. Donkeys. When do donkeys appear? People often think of horses as the primary thing for people riding. Donkeys were domesticated earlier. We have now good DNA evidence, or ancient DNA evidence for domestication of donkeys coming out of northeastern Africa and places like Somalia and Sudan, sometime after 5,000 or so BCE. By 4,000 BCE, they're for sure domesticated, and they show up in large numbers across the Middle East by 3,500 BCE. It's like they're domesticated and they spread like wildfire. Donkeys are great because they can carry goods, people over uneven terrain where wagons can't, or sledges can't really go. So all of a sudden, what we start seeing is a dramatic increase in the volume of trade. Goods being carried across the Near East, all kinds of stone, metals, and things like that are being transported. We know from records in Egypt that they are, that they're mining copper in Jordan and shipping tons of it each year to Egypt during the Pharaonic period. And who's carrying it? Asses. And donkeys are not always, we think of donkey as the poor man's animal. They're not. In the Chalcolithic, Bronze Age, donkeys are carrying kings. They're carrying the royalty. They're going to war, riding these animals. So donkeys were our best friends for a long time. Then they get supplanted by horses. But not really supplanted, because horses get domesticated sometime about, we used to think about 3,000, 3,500 BCE. Now we're pretty sure that that horses are only domesticated after 2,500 BCE, somewhere in the steppes of Russia, Ukraine, and they spread like wildfire across, but they're expensive. Horses are much more expensive to maintain, those of you who do horse breeding know this, than donkeys. Donkeys eat lots of different foods. Horses eat a much narrower range of food. But once they start using horses, which can run faster, this leads to revolutions in herding styles and warfare and social dominance. The elites can afford to keep and maintain horses. And so these are, a rich man's animals, so to speak. Hunting, herding, companionship, these all kind of blend into each other, even though you may not be, nobody can say that cats, for example, we've learned today with the genetics, cats can't be, we're not domesticated for anything purposely until much, much later. But by 10,000 BC, 10,000 years ago, an example from Cyprus is really good. They could be used for controlling rodent infestations. They could be good for companionship, but they're not domesticated. And that's cats and dogs you can tame. And that's very likely what happened. So the secondary products revolution, which isn't a revolution, it's a process. It's something that happens slowly over time. It takes thousands of years for secondary products of different animals to develop, just like it took thousands of years to domesticate different animals. These create productive surpluses. This allows for specialization in food production. This becomes the basis of early and modern complex societies. It also brings in the taxman. So this is, primary products are the basis for early domestication of most animals, I would say except for dogs and cats. But secondary products becomes the one that allows us to create the societies that we live in today. And we see companionship and hunting appearing already in the Paleolithic. We see milking already in the pottery Neolithic after 8,000 years ago. We see wool and traction after 4,000 BCE, and we see riding and transport also after 4,000 or so BCE. And also this leads to changes in landscape use. So we can see here in Europe and in the Near East, and it's different in the Mediterranean climate versus Central European climate. You get transhuman pastoralism with the earliest animal domestication, because you've got to get the sheep or goats or cattle out of the lowlands in the summer, and so in the Mediterranean world, you bring them up into the mountains early. But in Central Europe, that doesn't happen until the Chalcolithic, and what that does is lead to the colonization of the Alpine zone where we are. Only after about 3,000, 3,500 or BCE do we see that kind of thing. And so, just in conclusion, we exploit animals, domestic animals, for their primary and their secondary products. This creates the foundations of the modern economies, the modern social order that we all live within today. And I just want to say thank you.
Thank you very much, Professor Greenfield.
It's a real sign, as you exit Timna.
Thank you. I will let you sit in the audience, and I will call you back for the podium discussion. Thank you very much, and it's for me a big pleasure to introduce you the last speaker of this morning plenary session is Professor Laurent Frantz, Professor of Paleogenomics at the Ludwig Maximum University of Munich, with expertise in paleogenomics, bioinformatics, and evolutionary genomics, particularly focused on domestication of animal. He has led multiple important studies, including animal and pathogen paleogenomes, such as first ancient dog, pig, wolf, and Marek disease genomes. So, Professor Frantz, the stage is yours.
All right, thank you very much for sticking around, and thank you very much to the organizer for inviting me. This is my first Eaap, so this is quite exciting for me. So today I'd like to take you through some of the recent work that we've been doing in our lab, using genomics to track down the evolutionary history of domestic animals. So when I wrote the abstract and the title, I wasn't really sure which story I was going to tell you. So I put both pets and livestock, but I realized that probably you guys are more interested in livestock. So I'm going to stick to livestock today. But just before I go into these stories, I just want to give you a sort of broad overview of what we're doing in our lab. So we spend a lot of time looking at ancient genomes of dogs and wolves, for example, and trying to track the origin of dogs, so working on really on prehistory. But we also use genomes to try to understand the impact that recent breeding techniques have, how this has affected the genomes of animals. We do spend a lot of time as well on wildlife, so we look at how the genome of animals changes as due to overhunting or deforestations and things like this. So we have a pretty broad interest. And so to do this, to address these questions, what we do is we look at genomes. So genomes have these long stretches of A, T, G, and C have gigantic amount of information about history, the evolutionary history of an animal. And so we can just tap into that information to try to reconstruct evolutionary processes through time. The point is that doing this with modern genome is quite difficult. It's because we're really at the end of a very long-term process, and we've seen with these talks earlier that animal domestication, for example, is a very long, protracted process that takes thousands of years. And just looking at the end process, and I'll show you, is really difficult to sort of go back in time and try to make sense of how the genome evolved. And so what we can do now is paleogenomic, is we can go back in time, we can go into archaeological sites, sample bones, and then sequence the genome of these individuals that lived hundreds or thousands of years ago. And that allows us to track these processes over time, like a time machine in some ways. What we need to do, though, is that there's significant issues with doing paleogenomics. One of the main issues is contamination. So we have to work with these bones that have very little amount of endogenous DNA, so the DNA of the organism that died. And so we have to work in very clean conditions in these labs that are very clean, but also with positive air pressure. We wear these space suits, like here on this picture, and so to try to minimize the amount of contamination coming from the environment, but mostly from ourselves. A lot of the major contamination hazard is us with our hair and skin. So you also have to work with thousands of individual bonds because the vast majority of the bonds that we work with have 0 to little DNA, not enough to sequence a genome. So we have to go and process hundreds or thousands of individual bonds. And so for this, we've developed robotic workflows where we can just process a vast amount of bonds to find the one that actually can help us address our questions. Okay, so before I go into the results of what we can do with this ancient DNA data, I would just try to bring you a little bit of a background. This was mentioned a little bit before, but I was just trying to talk to you a little bit about the spread of farming technologies, and I'll show you a couple of stories that we are addressing with our data. Farming, we know from archaeology that farming didn't really start as a global phenomenon, but it started in sort of local areas across the world, and then this farming technology was spread outside of these centers of origin. And so we have here, for the purpose of this talk today, I'll talk about 2 centers of origin. One is in the Near East, where we have the domestication of goats, cattle, sheep, but also pigs, but also barley and wheat, which happened roughly maybe a bit over 10,000 years ago, give or take, depending which species you're talking about. And then the other one, which is I'm going to talk a lot more today about, is the domestication area in origin of agriculture area in Asia, which is a little bit later, but also we have the domestication of pigs, so really independently from happening in the Near East, but also the domestication of chickens, definitely much later as well, as Gregor showed it earlier. So what I want to talk to you today about is what happened where people are taking domestic animals outside of these senses of domestication, what happened to the ecosystem in which these animals are being brought to, and what happened to the biology of the animals that are being transported out of these regions. So the first stories I want to talk to you about is about pigs, and it's about the impact of when people are taking pigs in large numbers out of the Southeast Asia, the domestication center, into East Asian and island Southeast Asian, and all the way into Oceania. And particularly what happened to the local ecosystem as these pigs are being transported. The other story I want to talk to you about is, again, chickens, so following up on what Gregor was saying, about the impact of the spread of chickens, but this time not on the ecosystem, but on the chicken themselves. So how did the biology of chickens adapt from moving from tropical jungles to temperate climates in Europe? So let's first start with the pigs. So island Southeast Asia has a huge amount of diversity of pigs. Wild species of pigs. We have multiple species, more than anywhere else in the world. So you have these different subspecies, but also a Babirusa, which is quite a divergent lineage, that are found here in the islands of Southeast Asia. And they've been interacting with people as a source of food, being hunted probably for a very long time. In fact, some of these cave paintings that you see on the slides are probably some of the earliest cave painting in the world, much earlier than anything we find in Europe, so 45,000 years ago. So there's a really deep-rooted relationship between people and pigs as a hunting animal, and they still continue today in places, especially like in Borneo, I showed it by this picture of Dayaks there. So what we have is mostly these species of pigs that are found mostly on the western side of Indonesia here, in the western side of what we call the Wallace Line, which you can see here. There's only one species that's beyond the Wallace Line. So the Wallace Line is a really interesting biogeographic boundary that was sort of drawn up on the map by Alfred Russel Wallace, which was a contemporary to Darwin. And what he noticed is that the Asian and the sort of Oceanian biota, flora and fauna are very different across this zone that we call Wallacea here, and specifically across this specific line here. So the two are very, very different species. What we know from biogeographic studies is that we don't expect to have any native wild pigs beyond Sulawesi, so that's S-shaped island here. So there's not supposed to be any pigs natively occurring in these regions. This is a region where you have much more marsupials, not eutherian mammals. However, today we do find pigs all over the place in these islands. In fact, most of these islands, the thousands of islands you have in between Indonesia and all the way to Hawaii, have pigs on them. Living at domestic pigs as well, so pigs that are managed by people, maybe not in the same way as we're thinking of domestic pigs in this audience, like managed in large scale, but we do have domestic pigs that are managed, like in Vanuatu and in Papua New Guinea. And so here in this map, you can see the samples that we have available for this study. A lot of these samples that we got are from 19th century, so these are the dates, or 20th century. These are the dates in which these pigs were shot by naturalists. They were shot in these islands, they were brought back to Natural History Museum in Europe, and then we were able to access these and actually extract DNA and sequence the genome out of these things. And so what this is showing is that we were able, just from natural history collection, to show that there was pigs on all these islands here, and in fact, probably every single, the map doesn't have the right resolution here, you would see a lot more islands in these regions. Probably any island of significant size will have pigs on them. So domestic in some cases, but a lot of wild pigs as well. So the vast majority of these samples that we've got were from pigs that were not managed by people, but actually pigs that live on their own, and they've been, that basically can, what we would call feral or wild pigs. And so, for example, what's really interesting, what I find really fascinating is that if you go here and let's assume that here in the Komodo Island, where home of the Komodo dragons, you will find pigs on the island, which are one of the main meal of Komodo dragons. The point is that the Komodo dragon is very endangered, so very well protected. The pigs are kind of protected as well because they're a source of food. The question that we have is these pigs are not supposed to be there. They're probably being brought by humans in this region. We don't really know for how long, and this is something I'll talk about a little bit today. But definitely what this suggests is that pigs have been brought into these islands a very long time ago. They have time to adapt to this local ecosystem, and they're now an integral part of these ecosystems. The question that we have is, where are these pigs that are beyond the Wallace line coming from? And so this is what we're trying to address with these genomes. So what we could do when you start doing these sort of analysis, what you do is you start taking every single genome and you're trying to split them into ancestry, different ancestries. You take like reference population and say how much of this genome is coming from this population, how much of this genome is coming from this one. So we can have different sources where we can try to paint our genomes. So it's just different species. We also have Asian domestic and wild pigs, so this gray, the gray ancestry here, but also have European pigs, which I'll talk a little bit later. And what you can see in this region, east of the Wallace line, is just basically a bit of a mess. There's a lot of this gray ancestry coming from Asian pigs. There's a little bit of orange coming from Sulawesi here, and there's quite a bit of blue in these places coming from these European pigs. So there's definitely a mix of things that are happening. There's a little bit of this green one as well that seems to have leaked through the Wallace line here. I'll go back to this a little bit later. So it's quite a bit complicated, and it seems that the pigs that we find in this region where there's not supposed to be pigs have very different and diverse sources. What I want to focus on today really is this gray ancestry that we see on the map here, which is linked to the Asian pigs that we see mostly on the mainland. So Asian domestic and wild pigs that are coming from the source of Asian domestic pigs in South China. But this is also found here in wild boars here, also in Sumatra and Java, so also in the islands as well. So one of the questions that we have is, where are these individuals coming from? One possibility is that there is a movement, people moving pigs from these regions, or maybe somehow potentially partly naturally, these pigs are moving in, and then they're somehow moved by people from this source here into these islands. The other question that we have that we will address, and I'll explain to you why in a minute, is whether they are coming from the mainland here, as domestic pigs that were transported by people with the farming technologies. Why we are thinking this is that these roots here is the backdrop of one of the last and probably most profound, last and sort of long-distance expansion of farming technologies out of center of domestication that took place across the planet. This is the expansion of what we call Austronesian speakers, which started about over 3,500 years ago. So people moving from Taiwan with farming technologies and with different kind of boats, they had pots, they definitely had rice, and potentially had animals like pigs and chickens. And so they migrate, over quite a long time over these areas, and then they finally reach Polynesia about 1,200 years ago. And so the question that we have is, are these pigs that we find in these islands related to these pigs that were brought from domestic pigs that were brought in during this agricultural introduction of agricultural farming practices in the region, and then they became feral and started populating all these islands. So the way that we can do this is we can go to ancient DNA and try to get, we got samples from colleagues, archaeological samples from archaeologists in the island of Vanuatu here. So this is almost a 3,000 years old sample from a pig that would died at a site that is definitely a Austronesian site. So this is one of the type sites from the Austronesian expansion. So the people that were living there were definitely descendants of people that had left this place about 4,000 years ago. We know that from the material culture, from the pots, but also from the radiocarbon date of the pig. So what we can do is we can say, okay, we definitely know these are the pigs that were together with the Austronesian. How does this genome relate to the pigs that we find, in this part of the Wallace line, and whether is it coming from here or is it coming from this region? So there's a lot of, kind of nitty-gritty detail that you need to go before you can get this neat picture. It's quite of a complicated process because actually a lot of these pigs here in these regions have mixed ancestry. But when we isolate the Asian pig ancestry out of their genome, what we can do is we can compare every genome to the Vanuatu pig and say, like basically the more red you are, the more closely related you are to the Vanuatu pig. And basically what we can see is the Vanuatu pig is very closely related, genetically really related to everything that we find east of the Wallace line. So all these genomes of these pigs here, most of which are wild or feral, so they're occurring in the wild, are actually descendants of pigs that were brought by the Austronesian. But what's really even more interesting is that the pigs that are coming from here are not actually being transported or displaced from this region, which is much closer. Their best proxy on outside of the Wallace region, Wallacea, is mostly coming from the mainland here as domestic pigs that we find today in Southeast China and Hainan, but also in Taiwan here. So what this is showing is basically we have a movement of pigs out of Southeast Asia in this region from where domestic pigs that were brought in more than 4,000 years ago, or 3,000 years ago, into these regions. These pigs then became feral and sort of radiated across all these islands. And so now if you go back to islands in this region, that is either in Vanuatu, but also in Papua New Guinea, and any of these islands, but also all the way to Hawaii, the pigs that you find there have been there for a very, very long time, at least, comparatively to the recent pigs introduced by Europeans, which I'll show you in a minute. But so what's really interesting to us is that the pigs that are in these regions in Vanuatu, particularly the pigs that are very ingrained in the local cultures in Vanuatu, are definitely descendants of these Austronesian expansion. And so these deep-rooted culture of people relying on pigs for various aspects of their life, meaning just also ceremonial, but also food, are really old and coming from this Austronesian expansion. So to summarize this story, I would just like quickly to go through these different processes that we see happening beyond, except for the after the Austronesian and before the Austronesian expansion. So the first thing that we see when we put it all together is that we have a little bit of this Javanese warty pig leakage of ancestry that are coming here. We think that this is happening more than 4,000 years ago. Whether humans were involved in this is really not clear. What we really see, though, is that by sometimes since the Pleistocene, we don't really know when, but at least more than 4,000 years ago, this species is of Sulawesi warty pig that's coming from Sulawesi here was translocated by people outside of this region in all the places here, particularly in the Lesser Sunda, but also in the Malukus. And this was maybe done by the same people that did the cave painting. The reason for it, we don't know, but these were not domestic pigs. They were wild pigs that were transported by people. We then have the third step here in a process that we can find from our data, which is the introduction of domestic pigs from South China and Taiwan as part of the Austronesian expansion. This is probably the most profound impact in the region, in the local region's ecosystem. You can imagine that after this expansion, we can't tell exactly how many years after this, but a few thousand years or a few hundred years after this, most islands in these regions had pigs on them, and you can imagine the environmental impact that would have had. What we also find is clear evidence that there is an introduction of domestic pigs from Europe that also get released in the wild and also interbreed with local feral wild species, and then we also make a contribution to these. And in fact, this is what you find mostly in New Caledonia, but also actually in Australia and New Zealand. The only thing that were introduced was actually the domestic pigs from Europe, and the Austronesian never actually been made it there. So what we're really interested in the next step is to try to figure out what is the biological implication for this on the genomes of the pigs as well themselves. So how these pigs have been able to adapt from being moved from these tropical region here to moving to sort of lower latitude and involved, probably meeting different kind of pathogens and having to adapt to living in much smaller groups as well in these small islands. Another story that I want to tell you today, rather on that side, is talking about the adaptation of the species when they are moved out of their domestication area is on chicken. So similar to pigs, these chickens were taken out of their domestication area and moved into brand new landscapes. But here it's perhaps a little bit even more significant in terms of how they had to adapt. For basically these tropical areas of Southeast Asia, where Gregor showed us probably where dry rice started to move into the range of the Jungophile. We have domestication here, and these animals that they're taken very far into Europe very rapidly, all the way into via the Middle East. So you've seen this slide earlier. So we know that chickens were domesticated in Asia, but before 3,200 years, maybe 3,500, 4,000. But it definitely in Europe by 2,600, so probably a little bit better before. These are radiocarbon dates. That means the chickens must have been there before this. So it's quite of a short time frame that you have to move between this place and this place. And in fact, they are quite far into Oceania by then too. What happened to the birds that were transported is quite significant here. We're talking about a tropical bird that's living in an area where the mean annual temperature is very high, and they have to adapt to living into the temperate climate of Europe. So you can imagine the sort of biological changes that would have happened in the genome of these chickens to be able to actually adapt to these changes. As Gregor showed you earlier, we think that for the vast majority of time the chickens were in Europe, they were not really a major source of food. So this here is an interesting graph from zoological archaeological data from the UK. And what it's telling us basically is that if you're looking at sites from the Iron Age to the late Romans, so a little bit before the Roman and a little bit and late Romans basically, what you're looking at the percentage of chickens at archaeological sites, most archaeological sites have less than 1% of the animals that you find at the sites are chickens. So that means that people are not actually having chickens in large scale, they're maybe not eating chickens, maybe they're using them for cockfighting or something else. What things really picked up for chickens is really, there's definitely in the Middle Ages, there's signal, but real change, transformational changes probably for them in the genome, at least from our perspective, would be really since the Second World War and at least the 1960s, is when chickens start outpacing every other livestock production, and this is when we start seeing massive biological changes in these animals. And a lot of people know a lot better than me about these, but the changes, the efficiency of genomics, of selection and now genomic selection on these animals is absolutely outstanding. And so just in 50 years, we've been able to transform these animals dramatically. And so one of the problems that we have in our lab is to try to distinguish between these two phenomena, right? What happens to the genomes when they are transported from Asia into Europe, and what happens to the genome when they are being selected really heavily in the last 50 or 60 years? So to do this, we can turn to ancient DNA, and it's very useful because we can then go back in time and sequence the genome of a few chickens. Like here we have about 100 ancient chickens from Western Eurasia, and that can allow us to disentangle these two questions. So we've been able to do this, so sequence about 150 genomes here. There's some really cool sites that we have in there. I don't have time to go to every one of them, but one of the ones that I find the most interesting is this site of Courgazot here, where the chicken that's about 2,200 years old, and it's found in this fort in the northernmost spread of the army of Alexander. So this was a fort that was built by the army of Alexander that had chicken on it. The number of chickens was very small, so it's probably not that they were actually a big source of food for the army of Alexander the Great, but so we don't really know what they were using them for. Maybe it was more cockfighting or some ceremonial purpose, but they were definitely already there in the backdrop by then. What we did is also team up with a lot of people from various institutions across Europe and North America to collect a lot of chicken genomes from modern individuals to try to basically create a reference manual for the analysis that we wanted to do with the ancient chickens. And so we were able to get about 5,000 chicken genomes together into one single analysis pipeline. And so merging this with our ancient genomes, we were able to do quite a bit of analysis to address these questions about old and recent selection. So let me walk through some of the basic results that we have for now. So this is a plot, this is a mixture plot, which showing the degree of different ancestry in chicken genomes. So every bar here is a chicken genome. You can't see the bar, but you can see basically these bars are one chicken genome, and they are painted in either blue, meaning they have a lot of European ancestry, this ancestry of the first chicken that were brought into Europe more than 2,000 years ago, and the tan color is a more East Asian ancestry. And so what we can see, obviously, in East Asia, a lot of birds are sort of pure tan. They have mostly this tan ancestry, which makes sense. And then when you go to the ancient birds, which are mostly European, they're mostly blue. That means that they have mostly these European ancestry. What we can see, though, is that when you're going to birds from North America today, these experimental line commercial birds and European fancy breeds, these are all Western birds. We can see very big differences. There's some birds that are 100% European and some birds that have a lot of significant impact of Asian ancestry. And this Asian ancestry is something that came in the 19th century. I don't have time to show you, but we can date this very well. And so what you can do is you can take, for example, two birds, a white layer or a broiler, and then you can ask a question of how much European ancestry. So this white layer, white leghorn, have huge amount of European ancestry and a little bit of Asian ancestry. When you go into a brown layer, for example, or dual purple birds here, they have a lot of East Asian ancestry. What we can also do with this massive amount of data is we can go to every chromosome, every part of the chromosome, and ask, is this piece inherited from a European or from an Asian bird? And we can make these pretty pictures here showing where in the few places where it's Asian, where actually this is located, or where the few blue places are located in the genome. You can do this with a lot of other chickens, so you can do this 5,000 chickens basically, and you can try to look at the regions that are blue in every European chicken. For example, that will tell us potentially a region that's been stayed, that has been resistant on interbreeding with Asian chickens that stay the same in every chicken that lives today in Europe. And so you can do this, use all sorts of other analysis to try to get a map of the chicken genome where you find interesting spots that may have been linked to basically, and that are biologically important for chickens. So this is here, every of these peaks are linked to basically how divergent chickens are. Well, actually here, this is how similar to birds in Europe are with respect to a neutral hypothesis. And so what we're trying to do here is trying to find each of these peaks and trying to find whether these peaks of significant biological changes, so potentially underlying very interesting genes, which one have been driven by selection when chickens first arrived to Europe, and which one have been driven by selection when chickens were selected for meat. And so with ancient DNA, you can do this. It's really useful. We can then, and you saw one of those plots from Gregor earlier, we can see this. We can make these plots and these analyses where you have, for example, here on the x-axis, years before present, and the allele frequency, so the frequency of genetic variants under selection. And here you can see this is how it looks like with recent selection. Selection starts after 250 years ago. This is a signal of recent selection, right? And then this is what it looks like when you have old selection. Selection definitely starts much lower, and the allele frequency of that variant sort of increase, but increase much faster than here. So we can then look at the ancient DNA and say, okay, these things can be classified old, these things can be classified as recent. So I would just like to walk through a couple of examples before I finish of two examples of two genes that we found in the selection in the chicken genome. So one of the genes that is very interesting to us is the GRIC2 gene, which is involved in thermoregulation, thermoreception for cold and other aspects of chicken biology, or mammal biology for that aspect. The other gene that we find that's also very interesting and these pics is the alpha amylase gene, which is involved in digestion. When we're looking at the profile of these things, we find dramatically different profile of the selection profile of these, from underlying these peaks here. Basically, the GRIC2 gene is a very old, probably more than 1,000 years, starting the selection and sort of increase in frequency to about 40% in the chicken population, whereas the amylase A is much faster and increased, and this is actually in the last population in a lot of broilers chicken. So we can see this as being a very different time frame for the selection of these two things. And so what we're suggesting is that the GRIC2 was important for the early adaptation of chickens to Europe, and whereas this gene was probably more interesting, useful for for breeders later on. So we can then go down to try to actually tie this to a function rather than just sort of leaving it at this and saying, well, we find a bunch of genes and we don't really know what they do, but here's the story. Now we have access to vast amount of information about the regulatory profile of these genes through the GTEx project led by Ling Zhao Fang in Aarhus University, who's done this for multiple species, when including chickens, where they went they took a lot of data, and from available data also generated a lot of data from RNA data generated for single organ, and so in different breeds, and they were able to basically provide this gigantic data set that we can now interrogate about finding what is the importance of the variants that we find and how do they affect the regulatory processes in chickens. So for example, here in the GRIC2 gene, we can see that this gene is very strongly expressed in the brain and the retina of birds, which makes sense if it's involved in thermoregulation for cold. So this is RNA expression that we find across different tissue, across thousands of individual chickens. You can also do what we call EQTL analysis, so you can try to quantify the impact of the haplotype that we find under selection in European chickens on gene expression of in these gigantic data sets. And what we can find is that the haplotype that's under selection in chickens seems to have a really strong impact on the regulation of this GRIC2 gene here. And the GRIC2 gene here, basically leading to the European haplotype is really leading to is downregulation. And this is really interesting because a few years ago, or like last year, there was a paper from Chinese researchers in neuroscience that did a really cool knockout study where they knocked out this gene in mice. And what they showed is that if you knock out a gene, this specific gene in mouse, this GRIC2 gene, mouse have a much higher tolerance to cold. So the mouse that didn't have this gene basically were able to sustain cold much longer in these experiments. And so what this is suggesting here is that what we think we are finding here is potentially a signal of a gene that was really important in the first instance when chickens were brought into Europe, based on all these lines of evidence, as potentially a way that chickens were able to adapt from their tropical origin into European climates. The last thing, the other gene, the alpha amylase, which seems to be selected much more recently, the RNA data is a little bit less, is a bit more complicated. It seems to be expressed in a lot of different tissue, but the first tissue that we find it is in the liver. And then we can do the same thing and again find the same story that we find the haplotype under selection seems to have a really strong impact on the, in this case, upregulating alpha amylase in the liver very strongly. And so what we can see, and also this whole region where you find the alpha amylase is overlapping with this quantitative trait locus, which is 14 QTLs with 4 different traits, all involved in sort of feed intake and growth rate in chickens. And again, we're thinking here, this is what we're finding is that this is really a signal of what happened to the chicken genome when we started selecting for bigger and bigger chickens. All right, so I hope I've convinced you that ancient DNA is a really useful tool to address these sort of long-term questions about the evolution of animals, even for addressing questions that may be relevant as well for agricultural science. And with this, I will, this is a lot of collaborators have been involved. So Gregor here, for example, a lot of these studies have been done in collaboration with him, but also a lot of collaborators involved, particularly archaeologists as well, in providing samples, and a lot of other collaborators around the world. And yeah, thank you very much for your attention.
Thank you very much, Professor Frantz. I would like now to invite the fourth speaker on the podium for a short discussion. Thank you very much. Thank you, gentlemen. I'm sure there is a lot of questions, but we have a very limited time. So I have some questions, but I don't want to take the advantage of my position. So I would like to open the discussion with questions coming from the audience. Yes?
Okay, I'm Achille from the University of Turin. I have two questions. One is more methodological question. I mean, we are quite obsessed by artificial intelligence in our scientific field. Is it the same for you? How do you use, if you use it in your activity to study the past? And another question is more related to the fact that in our activity, we have also to face with consumers that reject animal products, they are vegan or vegetarian. Are any evidence in the past if something similar occurred?
I guess this question was not raised to one particular audience, so first come, first served.
Okay. On the AI, I use AI actually to review my papers before I submit them. I just ask the AI, please be a PhD reviewing my paper. And I found it very productive. I mean, I take the remarks and then I work on them myself. I don't ask the AI to actually solve the problems that he raised. And I find it very productive.
For AI, I know that the GTEx, so the genotype expression studies, guys, because the data sets are so big, they're using this quite a lot. So they're using large language models. And so it's getting a little, more and more into genomics now, for sure. So in the genomic sites, I don't know in the archaeology. Did you guys use it in zooarchaeology that much? You have to press the button. Haskel.
We have failed to use AI in zooarchaeology because there's so many bone fragments and there's so many different shapes, and people are chopping up the bones. You know, if we have whole bones, it might be possible, but the technology is nowhere near what we can do with our traditional analyses. So, but having said that, it's a great way to edit your grammar. You know, and being the editor of an online journal, I get all kinds of people sending me manuscripts and in all kinds of stages of poor English. That, you know, so I encourage them, use the AI to rewrite, because it's a good tool for that, as long as you don't use it for your basic research.
For me, most of what I do with AI is get into fights with it. it's more adversarial. I'll ask it a question, then I ask it why it lied, and it's kind of fun to go back and forth with it because it will say, "Oh yes, I totally did lie," and I'm like, "Well, why did you do that?" And I said, "Well, maybe I don't know why I did that," and it's just I end up chatting with it as though it's a human being, and that freaks me out. So then I have to go do something else for a while. With regard to your question about vegetarian and veganism, as a relatively recent vegetarian myself, I don't know the super deep history of what it was going all the way back, but it is intriguing that you frame the question as like rejection of animal protein, as though that's like the norm. And I don't know that that's necessarily, or that's how vegetarians or vegans would necessarily think of themselves. It's like there's like a little bit of an othering that happens with that. And but I think that the deeper time history of it is certainly something that's worth exploring. And perhaps we could ask ChatGPT and see what it comes up with, or see what kind of it invents anyway.
But it also, with in terms of veganism, it's probably a relatively recent phenomenon that's in humanity, because if we look at great apes and the history of keeping them in zoos and feeding them foods that humans thought that early zookeepers did not give them any kind of animal protein. And yet, if you look at gorillas or chimpanzees in the wild, they're all eating substantial amounts of animal protein, along with the other plant foods that they're getting. And in the early 20th century, a lot of the gorillas and chimpanzees were sitting around and basically without any animal protein. They weren't getting vitamin B12 and brains were atrophying. So can veganism lead us down the pathway of brain atrophy in the future? That'll be an interesting subject for someone doing selective breeding.
At the same time, those same zookeepers, because when they had elephants and the elephants looked fierce, they were giving elephants beef and wine, and that's how they were feeding them. So yeah, zookeepers and food and animals has always been a bit complicated.
Exactly.
Someone else want to? Oh, I just wanted to ask the speaker if someone else want to complete or try to provide an answer to this second question.
Well, I think there's also, I think from zooarchaeology, there's quite a few, you can see like preference in specific species, right? So there's species that are more common, species that are less common. So I think the idea that some species can't be consumed for specific reasons is the reasons that probably we can't know from just the bones has been something that's been around for a very long time. But a sort of blanket not eating meat, I don't think you see this in the zooarchaeological record in large scale for sure.
Yeah, almost every site has, it's interesting that traditional archaeologists are not trained in soil science, which is what they dig. And they're not trained in zoology, which is, after ceramics and stone, it's the next most common material that we find in archaeological sites. It's often, you have to go for, it takes an individual going for special training to be able to do these. But most archaeologists are just poorly prepared to collect the data appropriately.
Thank you. I see a gentleman that came extra down to raise the question, so please.
My question is from Dr. Ben-Dor. That was really nice talk. Just wanted to know, what do you think about the future of human?
I really don't know. I'm sorry. I tend not to answer what I don't know, so I really don't know.
Is maybe another speaker want to try to answer this question?
What the future of humans?
Seems there is some consultation.
Well, you should go watch a movie from the 1970s called Soylent Green. That might be that's one pathway humans could be going down. I really recommend it if you want to see where we could be heading. But I mean, anybody who tries to control breeding of humans will go down. Will go down to failure. People find ways to procreate, to reproduce, and if you're doing any kind of controlled breeding, you're going to limit the amount of genetic variability that exists in the population, and we don't know what gene will help us survive as a species in the future. If we select it out because people want only blue-eyed, blonde-haired children or only males, you can't just have a population of only males. we need a population, a healthy population of females. They only need one of us. That's it. You know, so guys treat the women nicely. So yes, it's any kind of pathway for humans has to take advantage of our reproductive variability.
There is a gentleman on the 5th row behind the camera.
Yeah.
Please.
Hi. I have also two questions, mostly towards Professor Larson, but also to Professor Frantz. One is that about when you talk about the cats appearing in Egyptian, when the goddess bust become from a lion head, become a cat head, is it possible that it is a result of the Hyksos invasion? That's the first question. It's kind of niche, but I was just wondering. The second question is more general. It's about both rabbit and chicken becoming a common meat in Europe because of the religious reason that avoid four-legged meat. I was wondering because there is actually a similar phenomenon in Asia, especially in Japan during the Middle Ages. The Buddhist teaching forbids or almost forbids raising mammals for meat, and they allow birds, and they consider rabbit a bird in Japan. In China, there was something similar, but not as strong as, and it's only periodic. But in Japan, it lasts for hundreds of years. I was wondering if there's any evidence of similar development of basically non-traditional or non-mammalian or rabbits, small mammals, this kind of in cultures other than Europe or in East Asia or maybe even in Americas that come from religious or cultural prohibitions.
I think you're probably right at the edge of what any of us know anything about. That's a really great question. I think what's absolutely true is the relationship between, or how culture fits into all of this. And I think all of us, coming from kind of a more Western European tradition, it's about productivity, it's about calories, it's about things we can count and then consume. And we tend to, I think, at our own peril, discount the importance of cultural attitudes and feelings and the dynamism of all of that. And all you have to do is look for foods that get consumed during your childhood. Are those the ones that you kind of consider the most important? And then you go to a different culture somewhere and you realize that they eat very, very different things from you, but those are gross to you if you didn't eat them as a kid. And so for me, like having breakfast in East Asia is difficult because I like my pancakes and American sweetness stuff. But for them looking at me, I'm a complete idiot and that doesn't make any sense. But and then you can also see through the archaeological record, as Laurent was mentioning, zooarchaeologically, you can see how taboos rise as well. I mean, pig domestication in the Near East starts at about 9,000–10,000 years ago in Anatolia, and then by the late Iron Age, nobody's eating pigs anymore, even though that's effectively where they're starting. And so, and of course, then we're making up stories the whole time to justify all of that, and we're making some animals other animals and vice versa. So I think you're absolutely right, and the really fun thing would be to try and people are working on this, we know some of them, are looking at the historical, cultural influences on the consumption of different animals through space and time and how that changes with new things coming in and then things falling out of favor, and also how it's something will start as elite and then go and trickle down and then become accessible to populations that weren't initially had access to it, and then it becomes completely ignored by later populations. So we see that with fallow deer, for example, where they're introduced as an elite animal, everybody's hunting them, there's whole traditions around hunting them in Britain, then other people start consuming them, and now nobody eats meat probably because of Bambi, right? Like nobody wants to eat fallow deer in Europe, or at least in the UK as a result of that. So they end up exporting stuff to, or importing their venison from New Zealand, which also doesn't make any sense. So I don't know that there's a whole lot of rationality in all this, and that's what makes it interesting. It's a great question.
Just like horses in North America. You know, everybody's so concerned about all these, you know, what they call wild horses in North America. They're really feral horses, because they were domesticated, brought over by the Spaniards, went loose, and you know have adapted back to being in the wild. But everybody's so concerned about these animals and their welfare. Yet, because nobody eats horse basically in North America, where did the horses end up? In the dog and cat food factories. So.
But if they sneak into the human food chain, then it's all crazy, right? And that's what gets it. But there are some countries in Europe which eat them happily and others that don't.
Yeah, so it's very cultural.
And that's what, precisely. And it's the cultural element, which is on a very fine-grained, city to city, country to country basis, but we often act with kind of judgment over curiosity, right? Your first instinct when it comes to food is what I eat is normal and what you eat is different, and that's bad. And it's a really interesting phenomenon.
But I think in most cases it's really rare to be able to make these sort of link between culture and changes in animal production, because most of what we have is just bones or the DNA, but we don't have any historical record. So we could just observe something, there's a change in the sites and there's more pigs being consumed and less pigs being consumed. But the reason underlying it is, in prehistory is impossible almost, unless there is some sort of iconography or some sort of, but even then it's very hard to interpret. So it's very hard to know. But I agree with Greg, and most of it is probably driven by culture rather than actual choices that actually, sort of make sense in some, like, subsistence, because short-term choices is quite hard to make, and, they don't have scientific evidence or anything. So.
Thank you, gentlemen, for your very precise answer. I see actually a lot of people standing, just waiting for the questions. Please just try to be very short and formulating the question. And gentlemen, if you can also try to be very synthetic in your answer. Thank you very much.
No.
Please. Yes, I see. It's green. Try to speak.
I turn it on.
Yes, now it's here.
Hello, my name is Andrea Amaral. I'm from the University of Évora in Portugal. And my question is to Ben-Dor and also to the other speakers, if you have an opinion about it. Because so you've presented like you had hunter-gatherers and then you had farmers. And it was not like a bit like that. So until today, we have hunter-gatherers. So in Portugal, for example, we had hunter-gatherers during a Neolithic period near the sea, and we had farmers towards the interior. And in Évora, where I work, there is a large Neolithic site. And Mário Carvalho, who is an archaeologist, has been working in this for many years. And his opinion is that at the time would be similar, a choice similar for us today, like adopting a different religion. So it was a choice. It puts it in a choice because there was availability of natural resources there. And still today, we have human populations that are hunter-gatherers, mostly, and we derive from the people that made that choice a long time ago. So what would be your comment on this? Thank you.
Okay, of course, the transition was not as I presented it. If you have half an hour, you cannot spend a lot of time on the transition. For instance, there were villages in the Levant with hundreds and hundreds of people living in them and no sign of agriculture for a long period. So the transition is always murky, and it's always, but I think that still people had a choice for a while. But after a while, there was no choice. So the transition, yes, you present a picture of the transition, but in the end, everybody became farmer. Now, the recent hunter-gatherers, most of them are in rainforests. Or marginal deserts, where agriculture is quite difficult to do. So they're left there. For instance, those in rainforest, all of them actually practice horticulture. And some of them, in Congo, for instance, they are involved in trade with agriculture, with farmers. So they trade meat, for instance, elephant meat, with agricultural products. And I don't think they could survive, not only me, but other researchers as well, don't think that they could survive on their own in these marginal areas. The one group that is taken many, many times is the Hadza of Tanzania. And these people have been living with iron producing tribes around them for 500 years. So when you come today and you see a hunter-gatherer, which you think is pristine, it's not. It's using arrowheads with the iron tips. If he had to do everything from stone, he would have had to spend so much time. He wouldn't have other time. I wrote a whole paper about it, and then now it's another paper in a review about it. So this transition and the current is a complicated story. The end result is that most of us are farmers.
I'm very sorry, but
I just want to ask, but wouldn't you agree that while in some places could have been driven by biological resources, could have been due to other societal thoughts? For example, how do you put the Göbekli Tepe in Turkey within the story?
Well, I have my own opinion about that. It's I think that all the symbolic revolution that you find starting at Göbekli Tepe is actually a reaction of people to deal with stress. It's easy to see in the caves, cave art. So most of the cave art is of large prey. And it's a period when large prey started to disappear. So we're not going to sit here all day discussing it, but that's my opinion. That's the art is an expression of dealing with stress.
Thank you very much. I have this very unpleasant role to stop the discussion because we are already late, but I really want to deeply thank all the speakers for this very passionate presentation and discussion we had. So a big applause to all of you. Thanks to the audience that remained until the end. I'm sure that you were very interested in discussion, and for next year, the take-home message will be we need much more time for this very interesting podium discussion that we have. And the last information, it's if you have missed some information, so do not worry. All the award ceremony, all the plenary session have been recorded and is live streamed in our YouTube channel. So you can see all the presentation one more time. You can see the discussion, and maybe you can take contact with the speaker if you have some question. I'm sure that they will be very happy to answer your question through email or maybe phone call. Thank you very much. Enjoy the lunch, and I hope that you were enjoying the plenary session.